Morning.
Morning all. My screen hopefully is shared. It's been a bit of a last minute-ish tweak to the agenda. Although so Verum can't make it, unfortunately, so that sort of freed up that slot. And also Alessandro, are you here, Alessandro? I said I would squeeze you in at the start, but no, you're not here. He had some time constraints also to fit in with. Okay, so
I think Cesare is here, so maybe he can also give something. Cesare, are you here?
Oh yeah, Cesare is here.
Hello, good morning. Yes, yes, but
you...
no, I'm not going to present. I think Alessandro had to prepare something.
Okay.
Yeah, it's only
okay.
Well, maybe we can squeeze that in at the appropriate moment. Be a bit flexible on that one. Okay, so here's the agenda. Usual format. We'll skip through each of the building blocks with a 15-20 minute demo and a general status update. The break, I've tried to just put that midway through, but again, we can be flexible depending on how things are running. So let's therefore kick off with Jonas and the DLR team.
Yes, thank you so much. I think we've made in general good progress in each of the building blocks. And therefore, I will directly hand over to Angelos and Jonas for the resource discovery building block.
Thank you. 1 second to share my screen. I think I will share the entire screen because I'm not sure if it's going to. All right. Can you see that?
Yeah, coming through.
All right. Yep. All right. Great. All right. Good morning, everyone. Let's start with the resource discovery building block. We have some slides, and then we have a short demo. So let's start with the resource catalog, the progress made in the last quarter. Some of these things are going to be demonstrated along with the registration API later. So I will selectively do a demo on this one and then move some things there. So first of all, we accomplished during the builds coaching, we finished the abstract backend support in PyCSW, which means that now we have a layer of abstraction between the backend module and the API module, and that gives us the flexibility on the next quarter to achieve Elasticsearch support and other backends. So this has been completed. It is an open pull request on upstream PyCSW, and we are just waiting for review and merge. But the work has been completed. Then we have added the support for pub sub workflows in PyCSW, and this is the major part of the demo in a few minutes. So now we have completed a generic interface inside PyCSW that actually connects to a broker, and then on every transaction of PyCSW, we get to see notifications. So the first pass, let's say the first implementation of this, is compatible with the current OGC PubSub swig, with a draft document of OGC, which means that I'm going to demonstrate something which is based on an MQTT broker, and we will work later for cloud native connectivity. We also then we did some changes to PyCSW to implement to align, let's say, better with the stack, with the CEO's stack best practice. So in this quarter we had 4 or 5 pull requests on some minor issues there in the best practice, and we moved that along. We did an initial support for Jupyter Notebook resource type, based on the feedback we received from Earthcode as well. And then we also did some drafting, and we are getting ready to work further on the metadata profile, on the EOEPCA metadata profile. Also, we tested some MLOps artifacts. This is going to be shown in the registration API. We continued our work in the OGC API record swig. The second part, the facets part, is ongoing. And now we are also moving to part 3, which is harvesting and federation. Federation is planned not for the next quarter, but the next one. Of course, we continued maintaining OGC API records and Stack API, and we did some documentation updates.
Just to break in there, Angelos, yep. Salvatore's, you've got your hand up?
Sorry, I don't see my screen. So
it's okay.
Yes, I have an hand up. No, I just wanted to know, you said you got some pull requests for the COX stack compatibility. From who were they?
Sorry, we did we implemented some pull requests internally so that we align with the best practice document. So it has been sent from.
Okay, but I mean yes, but the requests were coming from yourself or they were from external contributor. I just wanted to understand if there were also external contributors which were merged upstream or it was all your work.
No, it is a core PyCSW team, so it was from within the team. So it's not external. No.
No, just because we try to show the, let's say, the collaboration was from outside what we sponsor was an in-kind contribution. It was good to point it out. That's why I wanted to know. But if this was anyway all work sponsored by us, then it's okay.
Yeah, it was done during the sprint also. So we had during the code sprint we went through this as well. No, we didn't have any external contribution from outside PyCSW or outside the EOEPCA, if that is the question. I might be wrong. I mean, I have to look again if I miss something. Maybe I have to check again if there's one pull request from external sources, but I have to see that again. I don't have it in mind right now. Okay. Any other questions?
I suppose just to back that up, Angelos, I guess as a general thing for the project, it's useful for us to know where we are getting sort of community contributions. Let's say external contributions. That's useful knowledge for us as well.
Mm-hmm. Yeah. Okay. Noted. Shall I move forward?
Yes, please. Yeah, go ahead.
All right. Okay. So right now we have the the latest version of the resource catalog on developed cluster. We are waiting for the 2.0 release to be tagged. So this we need maybe to discuss if we need to do this now or in a few weeks. I would expect some discussion on this, and we have some updates on the demo notebook. Then for the next quarter, for the resource catalog, we have, as I already said, Elasticsearch backend support in the roadmap. We are going to also move to cloud event-based PubSub support. So we already had a long discussion with the notification building block during the Bits code sprint, and we know how to move forward and collaborate. We are going to support additional.
Sorry, can I quickly ask, Angelos? Sorry. On that topic, how will that relate to what you just described about the OGC PubSub? That bit's not quite clear to me.
Okay, the current PubSub support is based on the Swig work, and it's so the implementation was based not on cloud events. It was based on a simple broker connecting to the resource catalog. So this is already supported. We are already doing what the OGC current documentation is describing.
Yeah.
But as we discussed in bits during the code sprint, we will now try to map what the OGC document is describing to what the cloud event based architecture is providing, and by doing this mapping and maybe working with the notification building block, and we had a long discussions there about the how to align those two together. I think that now we can move to connect, like to make a plugin to connect to cloud event based architecture in PyCW, and that part is missing, but the generic interface of PubSub is there. So now what we need to do is implement another a parallel configuration instead of working with MQTT to work with cloud events and HTTP requests and so on. So we are ready to work towards that right now.
And in doing so, we won't lose the compatibility layer we have with the OGC PubSub.
No, I think not, but definitely we need to do this mapping exercise to see how this map between those two architectures. But
understood. Marian, you also have your hand up there.
Yeah, I want to supplement what Angelo said. It's basically cloud events is just a different envelope of instead of MQTT or other mechanisms. There are a few conventions which we started discussing in the long and nice discussions in Latvia, and I think we are nearing something. So I'm confident that it's a simple matter of mapping, let's say, the data model. But part of it will be visible in today's demo. So
yeah, perfect. Okay.
Yeah. Thank you.
Thanks, Anglos.
All right, just to summarize here, we have some other tasks for the next quarter, like additional resource types, metadata profile. We have we are planning to work on that as well, and of course the service integration to Terabyte is something that we also need to complete, along with some maintenance tasks. Okay, so these are there are also some data catalog. There is some data catalog progress for this quarter, but Jonas is going to cover this in the data access presentation later, just to merge things up and help the demo flow here. But of course, for the next quarter, we are going to demonstrate Tyler deployment with PyCW Stack API and Elasticsearch. So there are things that we have planned for the next quarter, and additional features that have been discussed with the steering committee right now, like extend for file format support to GeoZar, EOPF, ZAR, and irregular grid netcdf. Data Explorer user interface and cross-catalog search. These are things that have been discussed in the steering committee and are also planned for the data catalog for the next quarter. So yeah, that sums up the presentation. So now I'm going to proceed with the demo. So basically, I will just switch to a local setup I have, because the MQTT part is not in the developed cluster. So I have currently a setup here. So I have a local resource catalog, and I have a local registration API instance, and also I have an MQTT broker. So here is the connection to the broker. I have a local host MQTT. I connect, and here I see the tree of the messages. Here nothing is yet to be, nothing is yet submitted to this broker besides some system things. So what I'm going to demonstrate now, you can see here that we have one collection of items with the site data from the OGC inside. So we have 12 data sets. So what I'm going to do now is that I'm going to use the local registration API, and I'm going to register some items. So I'm going to the registration API. I'm opening up the Swagger interface, and then I'm going to use the registration here. So I'm going to register a simple item from this URL. This is the local resource catalog I'm having, and this is the MQTT this moment. So I execute. And this has been successfully registered, and you can see here that a new topic came up in the MQTT broker. So basically now we have a collection channel, and the collection channel now has the metadata main, which is the default collection in PyCSW. And here we have a message that already demonstrates that this record has been registered and has been submitted as a notification from the MQTT broker. And here you can see the history and the message. Basically, the message itself has the stack item integrated. It could be a reference. We have discussed this during the Latvia meeting. We have two options: either to have the full data inside the message, or we can have a reference to the record that has been created. In this case, we have configured this broker to accept the data itself, and every time we create something in a collection, then we have a topic underneath. So the pub sub here is aligning with the collections that are available in the resource catalog. So if we have different collections, then we have different channels in the broker, and then we can subscribe to different channels for a specific collection and get the messages only from that collection. So any kind of for example, I'm now going to do I'm going to delete now this record. It has been deleted, and you can see that we get a notification that this has been deleted as well. All right.
Is this linked to the behavior here? Is this linked to now you've got the abstraction in place? Is this on the layer above the abstraction, if you see what I mean, within the implementation as you plug in different database? Yeah, okay.
Yeah. So there is a pub sub interface that basically is triggered whenever we have a transaction update, delete, insert. And this interface can be configured in PyCSW to different endpoints. So that the change, I don't know if you want to see that information here, but if all right, so one second.
Just a few minutes till we need to move on to the next one.
Yeah, sorry. I'm going to give you the
lots of
YAML.
questions got asked.
Yeah. So here the pub sub. Yeah, thank you, Sandra. So this is basically what the configuration looks like in the PyCSW endpoint. So we basically define a broker, the type of the broker, and the URL of the broker, and we will implement cloud events here. So the type will change, and then the code will know which part of the implementation to use. So this is the plan. For now, we just implemented the MQTT type as a demo for this quarter.
Yeah, excellent. Yeah.
So yeah, let's. I have more things to show, but I will do it in the registration API. So I will stop here for a moment, so to save some time. If there are any other questions.
No, okay.
All right, thanks.
Thanks, Angelos.
Thanks. Got 15 minutes for the data access. Go for it.
I'll give back a few of those. Yeah, so yeah, for data access, basically what we did two things that we completed this quarter. There were so we started some others, but this was mainly what we completed. So the first thing, upon request from Terabyte, basically DLR, we implemented the option to use a centrally provided Postgres cluster, since that is a high maintenance piece of infrastructure, and you don't want too many of those hanging around just for different platform services. So we added the option that you can configure EOAPI to use centrally provided Postgres, and we're actually using the infrastructure as code included with EOAPI Kubernetes to provide this cluster, but then it's basically detached from the whole infrastructure stack and lives on its own. And then secondly, what really the most of the work was also related to PubSub, and here, like just as Angelos demonstrated, the nominal use case is that as soon as a new item is added, or of course there can be other operations, that a user can have some kind of processing triggered also, right? Like a new cloud-free scene over my area of interest, and I know I want to process that as soon as possible. That's kind of, there's of course tons of other use cases, but if we get this one right, then all of the other ones are also possible. And yeah, how we did this was we implemented some middleware, EOAPI notifier, that basically is connected, that's integrated or can be deployed with EOAPI Kubernetes, so with the data access building block. And for that, we implemented a new feature in PG Stack, so upstream, that basically sends a simple notification as soon as one of these operations happens. And we also connected that to the notifications building blocks Knative's Cloud Events sync. And yeah, so this is may sound simple, but across all of these projects, it was quite some coordination, and I'm quite happy we made that work. And also shout out to Marian. I think there was a really good collaboration going on with Felix here. And he will actually demonstrate the end-to-end use case. So I highlighted here in this little diagram, the blue one is basically what we implemented, but the whole chain would be that a harvester registers data in the data access stack that triggers this the cloud event source, and that you will see that also ends up in a sync. Any questions here? No. Then yeah, for next quarter, we have planned to deploy T-Tyler openEO via EOEPCA Kubernetes. So basically include that with the data access building block. And for those of you who don't remember, the goal with T-Tyler openEO is to enable synchronously running openEO graphs for data visualization or on the fly bandmath algorithm. So basically what T-Tyler can do when you make a request, but a lot more configurable. You can implement very complex algorithms similar to the Sentinel playground scripts, right, that you may have seen for hill shading, chlorophyll A computation, whatnot from Sentinel data. That type of workflows are possible with this simple T-Tyler openEO setup. So we want to make that a feature of the data access building block. And and then we have planned, which is something we already started, to implement tools for automated scalability and load testing of the Stack API or the Stack Palog. And the goal is here that platform operators like Terabyte can, in their infrastructure, test the performance of the setup. And finally, we want to do further development of the PubSub. There's some work left. I think some refinement of the message structure is still needed. The filtering is not yet implemented, so you can only get notifications on certain items or so. And finally, we want to implement hydration. So currently, I think the PG stack only notifies of the ID of the that was changed, of the object that was changed, but doesn't include the data. And that was intentional, so there isn't so much load always on the messages, but this should be an optional an option that this can be hydrated in the middleware, so you get the full data. I think, yeah, that was all my updates.
Thanks. I've got a question around the PubSub and the filtering. So does that mean a user would be able directly with T-Tiler be able to request notification for some specific filtered conditions? Is that what you're aiming for there?
With T-Tiler, you mean?
Yeah, so the notifications, rather than it just being tell me when there is some new data in this collection, it would be tell me when there is some new data in this collection over Italy or wherever, for example.
Yes, that's the goal. And that's basically SQL2 filters against, like you would run them against the Stack API, you could run them against the events basically, and say only, trigger or let me know when. And we figured that it would be useful to implement that in the middleware, because of course also a client could do that, right? A client could get all the events and so on, but we figured that this is probably a frequent enough use case, so it would be nice for people not to have to implement this on their end.
Mm-hmm.
But that's of course a different complexity, because you would need to register your query with the middleware basically, right? So you similar to what T-Tiler PG Stack does for dynamic mosaicing, this would be dynamic filtering on messages, you could say.
Yeah, there's some more hands there. Fabrice?
Yes, good morning. I wonder how T-Tiler fits in the picture, because, well, T-Tiler is stateless. It only sends tiles to a client requesting tiles. How would that fit in the picture? How would given data fitting one SQL2 filter would actually fit in a T-Tiler flow? I don't get it.
I think maybe we're mixed. I wasn't clear on how these things are separated. So the PubSub message filtering is not related to T-Tiler, right?
Yes, this is my understanding as well, Jonas.
Sorry, that's probably
Richard included it in the picture, so I have a hard time seeing how everything will mix.
Yes.
Yeah, sorry, my mistake.
Maybe one comparison I made there is that in T-Tiler, with T-Tiler PG Stack, it's currently not fully stateless. You can register a stack query, a search, basically a SQL2 filter, and basically the T-Tiler PG Stack saves that query and caches it on the data in PG Stack, and then you can request tiles for your query ID.
Yes, that is a scenario that exists for many years now. There's nothing new there.
No, this is not new. This is not new. But the similar kind of behavior we would want to implement on the PubSub. So that's where the comparison came in. that you can basically, as a user, say, I'm only interested in events that match this filter, and I want to like create a topic for my query. I think that's the plan we have.
And Titaler would map that to a
no connection to Titaler.
No. Okay, so there's no link with Titaler. Okay, removing out of my head.
Yeah, sorry, I gave a bad steer there.
No, yeah. Okay.
Blasi?
Yeah, a quick practical question. This new these new notifications, are they available somehow on the development cluster, and how can we potentially demonstrate this?
Yes, I'll let Marian get to his part in a sec, because we have a demo, and he can maybe share what the status is on having this ready on the development cluster.
Yeah,
Okay.
We'll be back on that in the
Okay,
demo.
so I kind of anticipated your next
Nice.
step, right? Okay.
Cliffhanger.
Is that part of the notification and automation section that's part of that demo? Yeah.
Yes.
Okay, makes sense.
So we prepare together with the development seat and Angelos.
Yeah.
Great.
Thank you.
Okay. Right, next is who's next, Richard?
Resource registration.
Resource
Probably.
registration, yeah.
We've already messed
Yes.
up slightly,
Yeah.
margin at least, so that's not a problem. But carry on.
All right, you got 15 minutes as well.
Yes, so good morning. Can you hear me?
Yes.
Okay, so I will be reporting about the resource registration building block achievements, and this will also be split between Angelos and myself. So I will start with the harvester related stuff and then hand over to Angelos for the registration API. Okay, so what we have done in this quarter regarding the harvester was also basically using the stack harvesting workflow we have developed in the last quarter also, and improving it in this quarter. So we added the override capabilities, which means that when you run these workflow multiple times from the same source, the items and the collections in the catalog will also be updated if there are any change. So this is this was not part of the previous quarter. So this is really an improvement when you rerun the same workflow several times, and then you can basically add things to the source, and then it will be updated in the destination catalog. We also did some improvements on the, let's say, operability of these of the harvester. There was a bug in the communication between the workflow engine and the worker, which was really nasty for operating, because once the connection, the network connection was there was an outage in the network connection between these two. There, you always had to restart every worker process, and this was really nasty for operation. And so we finally found this problem, and we fixed it. And we also, with the harvester, we also supported the end-to-end use case of the Datacube Access building block. So there was preparation done by Peter, and preparing the static stack catalog files, and then we used the harvester to actually insert a new collection into the data catalog, which is shown here. It's the NO2 collection, which is available there. And I have also put here some two log lines from the harvester, which shows the update capability, so to say. You see, this was run yesterday, and harvester was trying to add an item, and then received the conflict that it's already there, and then he immediately sent a put request afterwards to update the item. And this is just to kind of demonstrate how this is working behind the scenes. And I think the end-to-end use case will also be part of the Datacube Access presentation. So there we will see some more information. So I will go back one slide and then hand over the word to Angelos about for the progress about the registration API. Angelos.
Thank you, Mario. Just a few points there. We have achieved the registration of resources using the protected endpoints, and we are going to solve that in the EOAPI protected endpoint in a few minutes. We migrated the support for CWL from EOEPCA 1. This was initially done in the registrar of the data access of the previous EOEPCA. Now this has been migrated, the code has been migrated to the registration API. We did an experiment of the MLOps artifacts that I have to demonstrate that because I didn't do that in the catalog side, and we completed some terabyte requirements about the production deployment of the registration API, Docker security things, and various minor tasks there. Yeah, that's it from my side. Maybe we can.
Okay, then before we start the demo, I would suggest that we look at the next quarter. So for the registration API, we basically will extend the support for additional resource types. This is still to be defined, but this is the kind of work which is planned, and also regarding terabyte operation, we will support there. And for the harvester, we will add the functionality that we can also harvest dynamic stack catalog. So basically, we will not need to have some static JSON files laying around, but we can also point the harvester to a stack API, and then we will be options in the workflow whether to harvest the full catalog or just a specific collection or specific collections. And also, which we will lay hand on the Landsat and the Sentinel workflows, which we had done some quarters ago and not mentioned statements. As you might remember, Landsat and Sentinel workflows, their origin was on our terabyte platform, and then we migrated them into these into the EOEPCA context. And the use case here was that these both workflows also harvest the data, so that actually harvest metadata and also transfer data to a new location. And we will add the possibility that only the metadata is harvested and the data is left in the source where it is. And also make if the data is downloaded, we will also be able to have some different kind of sources where this data is then stored. That can be network locations, also instead of just local file storage. And yeah, there are also some terabyte specific features in there, which actually only applies to the terabyte use case. So we will make them optional so that both workflows can be used in a more general sense and support different kind of system integration scenarios or so. Okay, so this would be the outlook. And if there are no questions, I would again hand over to Angelos for the demo for the registration API.
All right, I will share my screen again. Okay, so first of all, I want to demonstrate the ability to register things on EOAPI, which is now protected. So I will try to be fast because I have many things to show. So basically, I will send a simple collection item. This is the input. This is inside the API. The endpoint is the developed cluster, and this is protected. So whenever here you will see that the collection was not here before. Now that has been completed, you can see the simple example collection here. And right now it is empty. So I'm going to also register an item. And I'm executing this, and in a few seconds, yep, we can see that if I refresh, this item shows up now. So I will. This is going to also be demonstrated by Marion. Is going to show you the notification part of this. So I will stop here regarding the registration of resources in EOAPI. I will switch.
Sorry, Angelos. Can I
Yes.
ask a very quick question? You said it was protected. So does that imply that there is some IAM going
Yep.
on there? If you see what I mean.
Yes.
Okay.
Yes. It is the similar protection that Mario demonstrated in the last quarter with Harvester. So the post, delete, and these HTTP verbs are protected right now with the OPA and API 6. So if you want to register, if you want to use the transactions on the catalog, on EOAPI, on the Stack API, you need to be authenticated. So basically, what we are doing, we are taking a client ID, we take a token from IAM, and then we use this token internally in the registration API to be able to register things in the catalog. So it's exactly the same thing that the harvester is doing against this protected endpoint.
Okay, thanks.
But it's not mandatory to have this protection, right?
No. This is just a configuration. If you go to the EOAPI deployment configuration, this is an OPA rule that is protecting the specific the delete and update and. Yes.
Okay.
So it is a custom rule inside OPA, and maybe Stefan can give us more details on that because he implemented that on the OPA. So yeah, the endpoint is protected. If I didn't have the token, I would get 400 errors. So this is how it works. Now I'm going to switch to the resource catalog. So my next demo is going to be with CWL. So now I'm going to register. I'm going to use again the registration API. I'm going to use a CWL file that we had in the previous EOEPCA demo. Now this is done directly in the registration API. It used to be through the registrar component back then, and I'm going to register this in the resource catalog using the OGC API records. So after I execute this, we had 40 results has been completed. I get the link, I refresh, and I have 41. And basically the CWL now is here. So we have a record that points to the CWL and some metadata that have been extracted directly from the CWL. It's the same functionality we had in EOEPCA 1 when we wanted to extract metadata from the CWL metadata. So this is the same, but we brought it back. Then very fast, I'm going to do the same for the example that we had for the Jupyter notebooks. So again, I'm going to register a Jupyter notebook. This is the record that has been provided by EarthCode. Maybe I can open this up. Sorry. So this is the EarthCode record that we are going to test. And now I'm doing an execution here. Again, using the OGC API records endpoint. Not sure why it's taking that long. And here we get the URL of the registered resource on the catalog. And here it is. So it has registered an OGC API record. It has validated that it's because the registration API validates the incoming record, and this is the same record now that is in the OGC API records endpoint.
And Angelos,
yes,
those resource types that you've shown there, and even the validation, that's what we are intending to sort of formalize perhaps a bit more as we go through this EOEPCA metadata profile that you mentioned earlier.
Exactly.
So we get a bit more formalism around that.
Yes, and if extra schemas come out of this exercise, then these schemas are going to be integrated in the registration API, and then on every registration we get to validate the incoming item against those schemas, and then decide, if this is valid, it will go through and be registered, or if it's not valid, we will get a meaningful error out of the registration API to give us some feedback on what is wrong with the registration process.
Mm-hmm.
The last part that I have been I want to show is the MLOps registration, because we had this from quite some time here. So what I'm going to register now is this URL from MLOps. We were given this stack item. It has the MLM extension, and we wanted to make sure that this can be registered in the resource catalog through the registration API. So I'm executing again. And the flood model should now be, sorry, this is the URL. Yes, and this is the flood model in the resource catalog with the JSON representation. Yeah, and then for everything I have shown, there are queries about deregistering these items, but I will save some time and not run through these parts. That's it from my side. If you have any questions.
Great, thanks, Angelos. I wonder if we should try and squeeze in Alessandro. I think you're here, aren't you? You wanted squeezing in before 10, didn't you? I think you said.
Yeah.
So
I don't want to mess up with the agenda, if that is not a problem.
Well,
currently running ahead of time, so I think we're okay.
Yeah. So you've got a little slot now. We'll squeeze you in if you're ready.
Thank you. Yes, sure. So hello everyone. Always a pleasure to be here. So just a couple of updates related to Ascend. So in the frame of Ascend, we are going to have an opening of the platform, which is going to happen mid of November, because the commissioning phase is going to be completed. So we have to welcome on board all the scientists that will exploit the OGC application package to run the BPS processor into the Insula platform, which is going to be offered to the community. In parallel with the OGC application package, in terms of interoperability with NASA, we're also working on the API gateway in a way that both the community will, working on both NASA map and DISA map, will have the possibility to exchange data and algorithm in a transparent way among the two different platforms. For what concerns the EOEPCA Plus activity, we are now working on the splitting of the isolating, let me say, the Arco workflow OGC application package interface in the API process, so that the component will be released into the EOEPCA repository, and of course will be operated by us into the Ascend platform. I don't know if there is any question or...
No. Very much.
Thank you.
Okay, yeah, we'll look forward to getting the feedback or understanding your feedback when you release go public, let's say in November.
Yeah, that will be, actually, it's going to be a lot of stress, and and also I also appreciate the different demonstration that I have the chance to attend today about Tyler, because we are also working on some implementation on that to exploit biomass data as well. So it's really interesting to see how synergies around these technologies are raising.
Yeah. And very quickly, have you got a set of users with application packages ready to go? How is that working?
No, not yet. I think the community will have to be, let me say, supported in this transition. So we are also working on example, and also this will be part of the R code, like example that we will help to support the building of application package into. So this is more or less our strategy, but now we have to deliver some of the feature that was requested for the 15th of November. So it's it's tough.
And you're aware of all of the online resources that TerraDue have created, instructional tutorials around application packages?
Yeah, absolutely.
Yeah,
we know that there is a lot of material also there.
Yeah. Okay, good. Okay, thanks for the update. Okay, so I think we're jumping back now to Datacube Access. Is that correct?
Yep.
Yes, that's correct. And I will hand over to Jurai and Matthias, as my colleague Peter is on vacation.
Yeah. Good morning. Can you see the screen?
Yeah.
Yes.
Okay, perfect.
Got 20 minutes. Yeah, go for it.
Okay. So some of the turn the camera on. So some of the updates from the Datacube Access. So as mentioned before, it was the NO2 data registration by Mario. Then as done in the previous quarter, also the Datacube Access stack catalog. We're currently having some discussions. Then a major updates are in the stack best practices, which I think Matthias will talk about in a little bit. And then we take these best practices and we are working on this end-to-end use case demonstration, which kind of integrates a lot of the building blocks, which will be also showcased in a bit. So I think if Matthias is here and give a little talk about the best practices. I don't see him. Okay, then I can cover for that. So originally we started researching the existing stack collections and catalogs on what different implementations are doing, and now we have started sort of developing the best practices, or which extensions, which kind of metadata fields shall be populated. And this has an ongoing discussion. Now the best practices have been kind of split into two different locations. So there is the kind of official, let's say, not only EOEPCA kind of led best practices, but this is open to the community, and I think still open to a lot of feedback and suggestions. So we'll share these links, I guess, after the demonstration, and if you have any feedback and suggestions, always welcome to contribute. And then we have a pull request in the Datacube Access, where there was also extensive discussion on the actual best practice that we have developed here in EOEPCA. So currently this is also still in progress, but it kind of describes how the dimensions shall be created, what sort of metadata be there. And so moving on.
There's a hand from Fabrice. I don't know.
Oh yeah,
yes,
sorry, Fabrice. Yeah, go ahead.
Go ahead.
No, well, just to say that I guess that this work has to carry on, because there was a lot of interesting discussions in the Stack Star sprint, and there was a dedicated slot on the Datacube extension. So I think there's a major reshuffle coming in from that stack sprint in Rome. So definitely, I just want to know how the stack best practice for Datacube being done in EOEPCA will align with what has been done with relation to ZAR, which is not so far away from the concepts that we're dealing with. Okay, and I just want to know how the inputs will work, because there's a lot of moving ground from Rome, a lot of moving ground from EOEPCA. It's kind of hard to understand if those two directions will converge at some time, and when is that time?
Yes, so I think regarding the Stack ZAR workshop, I think in the next Datacube Access meeting, we'll probably have to go over what were the discussions there, maybe have a more general EOEPCA kind of meeting to catch up on what the discussions there were with the ZAR. And then
yes, and maybe Jonas get Emmanuel on board in that discussion, and he spends half an hour kind of doing the summary of what happened in Rome last week, because it was really an interesting stack sprint, and the ZAR meetup here in Rome was really interesting. So just capturing the best of the two initiatives, but Matthias is definitely in both, but having a wrap up from Emmanuel.
Also, Michele from our team could join that. Jonas, he was
yes.
also in the
absolutely.
And he also
yeah. There was also from DLR there was quite a good presence.
On that topic, you were having regular sort of Datacube meetings, weren't you? Is that still happening? And if so,
yes.
I guess. And all of those people you mentioned there, so Emmanuel and whoever the other one was, I missed that one. Are they naturally, will they form part of that meeting, or do you need to make special efforts to get them involved?
Matthias
I think
is
Emmanuel
regularly
is
joining. Emmanuel not all the time, I think, but I think we can add him.
Yeah.
The same goes for Michele from our team, who we anyways assigned a few more hours also to join EOEPCA activities from our side now as well.
Yeah. Okay. So maybe, I don't know who leads those meetings, but who owns that meeting, let's say, but maybe they need to reach out and make sure the right people turn up on that one occasion.
Yeah, maybe it also depends a little bit on the topic that is specifically mentioned, but maybe for the maybe that would also we could think about a EOEPCA technical meeting about a summary of this the queue and ongoing work and the sprints that happened. Maybe
Yes.
next Tuesday.
Yeah. Sorry, I didn't quite catch it, but maybe you're suggesting we could have an EOEPCA meeting really to solicit, if you like, feedback from the stack sprint and what that means for us essentially. Yeah, I think that's a good idea. Yeah, I'll take that one on.
Thanks.
Okay. Sorry, and another quick question. There were two best practices you showed there. The one sort of the upstream one, if you like, at Radiant Earth, and then the EOEPCA one. How do they relate?
That I think would be a question for Matthias.
I can tell it to you too. Basically, we started with this work in EOEPCA, and then since Matthias was involved, we thought it's a good idea to push this also to the wider stack community, so that this has a bigger outreach and higher level of adoption in the future. So it's something that was born in EOEPCA, and then we thought it's good to also bring this to the stack community. And then Matthias took charge of this and added first a few issues, and then they started a whole discussion and finally agreed on having this documentation also on the official Radiant Earth. That's how the story went.
Yeah. Okay. Well, that's perfect.
I'm here again as well.
Oh, hi there, Matthias.
So yeah, so the Radiant Earth one is the one that the Stack PLC works on for Stack in general, which has pretty much everything that is non-EOEPCA specific. We have the Datacube specific part right now still in EOEPCA, but parts of that could also eventually evolve into the general best practices, unless you have anything that is EOEPCA specific, although I don't think there should be, probably.
No, I mean, for me, the ideal situation is there is nothing that's EOEPCA specific and everything is upstream. So,
yeah, exactly.
I realize that you know, it depends how far we went.
Yeah. It's a larger effort right now. So the Stack PLC in general is working on the best practices to reshuffle them. They've been living a long time in the official Stack repository, but were not updated for quite a long time. So that's a larger effort right now that's going on for the whole community, pretty much.
Yeah. Okay. Thanks.
Yeah. We can also join a Stack community meeting then, and bring what has been happening here.
Of course, yeah.
Well, it's one way or the other. We either bring Stack to EOEPCA or EOEPCA to Stack, but we definitely have to converge the outcomes of this work plus what has been discussed in Rome.
Yeah.
Yes, exactly.
But I think to some degree, Matthias, you've been you have been doing that, haven't you? To some degree, if I've read it correctly, anyway.
Yeah, so I'm leading a bit the general best practice effort, let's say, and the one in EOEPCA. Unfortunately, I wasn't able to travel to Rome, so I'm not really aware of what happened there yet. But eventually, I think we need to pick that up again as well, to ensure that it doesn't stall or anything, that effort, and then bring that eventually also over into the Stack best practices.
If I may, I'm sorry to interrupt the discussion, which was anyway very interesting, but it's more for our technical meeting than for the demo event. So
yes,
maybe we should proceed for the demo also because the time is short.
Yeah, sure. Okay, so then maybe before showing the notebook, we can quickly have a look at the Outlook. So for Datacube Access, we like to finish the end-to-end use case. So complete the integration one also with the CWL application packages as well as openEO process graphs, and then we are kind of looking into how to validate the best practices. So I mean, there are already existing validation tools, so maybe this can be extended. That's a kind of up for discussion. Then, as just discussed, I would like to finish kind of draft of the best practices, and then so after some discussions and some community engagement, I think we can go forward there, and then creating all the documentation for the building block for the practices. I think there's also the EOEPCA specific documentation, so we would like to contribute to that. And in terms of the registration part, there's some usability improvements, but we'll still have to figure out what exactly this will be. I don't know how much time is left.
You've got just under 10 minutes.
Yeah. Okay, great. Okay, so then just quickly, we can go over the end-to-end use case. So we'll not be running it because it will take quite some time, but there are some things I would like to point out. So first of all, so what this is we are taking two data sets. We are applying sort of the best practices as they are being developed, and then we are using the resource registration and the harvester to upload these to the EOEPCA Stack API, and then what we want to do is kind of have two different ways to go, either via CWL or openEO process graph to kind of load this data, perform some computation on it, and then again register that back to the Stack API as the result. So basically there's the workflow for both of the data sets. So first we get the cloud fraction data set comes from DLR, where we simply load the data and we have a copy of the JSON metadata. And so what we are doing then here extensively is keeping whatever existing metadata there already is and is relevant for us. And then from the data, we're extracting the data that is required by the best practices. So for example, the specific summaries and the assets, and then the Datacube extension, which has been quite a big talking point of this building block and is deemed an important kind of feature. Then creating the items, validating the collection, the catalog, and the items. Then what we showcase here from the data access notebook is how to delete an old collection, because before, as Mario showed, that there is this kind of auto updating process in the Stack API, but some time ago when we were trying it, it was not always working immediately, and when we want to kind of do a lot of changes, this is kind of a safer way, as well as showing how we can interact with the services. So we delete the old collection, and then the kind of workspace integration here, where we set up the authentication. We kind of prepare the workspace. We connect to it. We get the S3 information where we want to upload the generated JSONs. And then in this block, we upload our data to the workspace, from which we will then use the harvester to register these in the EOEPCA Stack API. And then what we want to do is we want to load the data. So currently here we will get into a couple of problems that have been observed. So first with ODC Stack, this part does work and we are able to load the data. And then with openEO, what we have tried is we use the CDSC backend and the EODC one, which runs the processes Dask, which will also be the backend in the openEO Argo workflows. And here we are running into two distinct issues, which are the load stack implementation related. So in the EODC backend, there is a complaint about some CRS not being recognized, even though in the implementation it should be auto added. So this seems to be kind of a bug because our collections are valid and have the CRS. And in CDSC, which we will probably need some support from Vito, is that the load stack, when you run load stack, it takes the URL and then it does the stack search kind of query, and this requires then authentication, even though it's maybe a setting in the EOEPCA stack, but basically if you just query the stack, normally you don't need to authenticate, but then if you do the kind of the search endpoint query, then that requires authentication. So these are currently preventing us from loading with openEO directly. This will be addressed in the next quarter when we will finalize the notebook. And then with the other collection, it basically is the same steps, but here, so we get the collection, However, here there are still, since Peter has been on holiday for a while, I tried to get the authentication to work because we need to extract some data from the data sets to fill in the best practices, but unfortunately there were still issues with this, but all the other preparation kind of has been done for the best practices. So this is probably a simple fix, but we were not able to do it in time. And then again, with the same workflow, we will upload the updated best practice compatible NO2 dataset to the EOEPCA stack. And then again, we will have the step where we load it, perform some calculations, and then so then in the end we will get the results back in them, and that's the status of the end-to-end use case right now. And I think that's it, unless Jonas, you have something to add for the Datacube Access.
Quick question.
Yeah, got time for a quick one.
From me, right? So essentially, obviously you flicked down that quite quickly. There's quite a lot to take in.
It's long.
Which is like, I understand we've got time. But so in essence, those early steps, you're essentially massaging the data, the information you're getting from the data source in order to satisfy the needs of the stack Datacube best practice.
Yes.
And then when you say you've had problems with the load stack in the two endpoints, where do you think the problem lies there? Is it on the EOEPCA side or on the other side?
No, I don't think it's on the EOEPCA side, because we can use the Open Datacube the load stack. I think these are kind of backend related issues. We can look into the processes task implementation of load stack, but since also the CDSE, so the Vito implementation is different, they're looking for different things. So no, I think it's not necessarily EOEPCA specific, but perhaps there could be some discussion or efforts made into kind of harmonizing load stack in general as a process to make it more consistent across backends. I think this could be useful.
And finally, the data assets themselves, where are they? They're obviously in the original source, I guess. That's
currently, yes.
Okay, and they're fully accessible without, unprotected, let's say.
For the cloud fractions, yes. I think for the NO2, which they are behind authentication, because that's what we kind of want to show.
Okay.
Yeah.
Okay.
See that Stefan and Jeroen have their hand up, so maybe they want to add.
Yeah. For load stack, actually for catalogs where the search API itself requires authentication, there indeed you need to work on standardization. I'm not sure if there is a clear way on how to actually get that done. So it would, I think load stack says that in that case it needs to work with pre-signed URLs on the openEO side, but that is of course only working if you actually have pre-signed URLs. The other question is, of course, why do you anyway mandate the use of an authenticated search endpoint? It's all way easier if you keep that public and just to require authentication for the actual data access. So yeah, there's a couple of things to harmonize here. But at this point, from the openEO side, if an API just says, okay, you don't have access, yeah, then it stops, of course, and we cannot we cannot do a lot.
Yep.
Yeah. Stefan?
That was, you just asked the question, didn't you?
Okay. Sorry, I hadn't realised it was the same person.
That's right.
Well, I guess that's the benefit of working through this end-to-end scenario. I suppose we'll flush out all of these technicalities. Thanks, Eurac.
Workspace is next, and you've got 20 minutes.
I think we have now the workspace building block from Stefan.
Yes, good morning. Let me share my screen. Is it coming up?
Yep.
Yep.
Good. So let me do an update on the workspace building block, where we stand. So just a short summary or an overview again. So a workspace, what does it do? So it brings together storage resources, which are object storage, but also other source types like NFS, to exchange data. Then it provides a runtime environment, which in the past was just a Kubernetes namespace, but that got extended over time also to support vClusters as this runtime environment to run different kinds of workloads in a user-created environment. And last but not least, it brings together domain-specific tooling. And in our case, this is usually some VS Code server-based data lab environment where you have specific command line tools and application services available, like AWS, CLI, or similar, to move data around. Yeah? And all these components, yeah, they are now managed declaratively on Kubernetes. So for each of them, there is a representation then in the Kubernetes cluster saying what is currently available here for the specific team of users. And it's orchestrated through the Workspace REST API. And now we also have a UI built on top of it, which I will also demonstrate during this presentation. Yeah. And just a short comment on this runtime environment. So, because we have multiple runtime environments within the EOEPCA ecosystem, and I think a good separation is that from the runtime environment from the workspace building block, this is always a user-curated thing, so where the users more or less specify how it should like, and the processing building block, it always deals with some specification which it applies and then runs large scale. So I think this distinction is quite important to always keep in mind when we talk about runtimes. Yeah. So what has been completed over the last quarter? So first, and the most visible one, so we finalized and come to a first release of the Workspace UI to really flexibly manage buckets and the access to buckets with other users. Then we integrated this browser-based tool for your object workspace, or for your object storage, and integrated it now into a dedicated tab in the data lab environment. So it's quite easy to approach. Then that's more on the technical and infrastructure level behind. So we cleanly separated this storage and this data lab components, so it's easier to deploy, and it also provides now standalone components, which are then just orchestrated through the Workspace API together. Then we also worked on some kind of what we call the auto session mode, so that if you start up a session, it's also possible to let it be shut down based on a schedule to save some resources in the cloud, and then to start it up on demand again. And I think the most important part, and I think because as we are now on a release schedule, is that we did a comprehensive update of the documentation, so you will find a lot of new stuff there, and through the quick start guide will be the thing where we now will follow through the demo. Yeah? But before we go there, just a short update on the upcoming priorities and plans. So we want to finalize this credential rollover mechanism we already have started, and also provide a different way on how to safely exchange more time-limited credentials instead of the long-lived credentials. Then we want to make relational storage a first-class citizen for all the user workloads, because if you deploy something in this vCluster, for example, yeah, it's more or less at the moment your responsibility to make sure that all the tools you deploy there, that they have properly persistence in the background. Yeah, and for relational storage, this is a quite common need for Stack API and similar. So at the moment you can deploy your own Postgres database, yeah, but then you have to manage it. And I think this is something which can be abstracted, and that's also a goal from the Terabyte perspective, to have here a better user journey. And last but not least, yeah, at the moment, when you are within a workspace, yeah, you can always add additional users to your workspace, but then at the moment they all have the same set of permissions. And here we want to introduce some kind of a role-based access model, so that at least the manager of the workspace, the owner, has more possibilities, capabilities than other users which are just onboarded. Yeah? So these are the plans for the next quarter. But now,
sorry, but just to
yes?
cut in there, Christoph, you've got your hand up. Did you have
Yes.
a comment there?
I wanted to ask, you said there's a difference between the workspace processing part and the processing building block, but I would be interested if a Jupyter Lab can be deployed in the workspace, or what the relation, for example, in the Jupyter Lab and the workspace could be.
Yeah, as the data lab environment, you will subsequently see. There you have, this is really directly connected to a Kubernetes cluster, and it's possible that you either spin up this Jupyter Lab in the data lab session directly, or you spin it up in the Jupyter cluster, yeah, and then just access it via that means, yeah. But the Jupyter Lab environment is usually, a Jupyter Lab session is usually not the way on how to run production workloads, but it's a good way to orchestrate production workloads. Yeah, from there, then you schedule to openEO or similar tasks to connect all the different pieces. So that's a way, but still the environment is driven by the user. So the user is responsible to start the Jupyter Lab session and have it there, and then goes out to the processing building block. So that's for sure doable. So does that answer your question? Or?
Yes, thank you.
Good. So let's come to the demo. So first of all, everything is deployed on the developed cluster. So if there is our common set of users available with Alice, Bob, and Eric, and we will now go through in the quick start guide, we will onboard another user. So just to highlight the steps. So first of all, we have the operator will provision a workspace for Frank, our new user. Then we will shortly explore the data lab capabilities with the VS Code server, which has all the tooling installed to check out the project, to run through the project, and then also to connect to the Kubernetes cluster to deploy a custom workload. And last but not least, I will also show how Frank is then able to invite Alice to his workspace, how he can access data from Bob, and how he allows Eric to stage his kind of data sets into Frank's data, so that more or less he can finally work on his project overall. But now let's go to our quick start guide. So here you can see, this is on the left side, you see the refreshed demo, and here is this quick start guide.
Stefan,
yes?
I don't know if it's just me, but I'm not getting anything. I'm getting a blank screen now.
Getting anything. Let me try.
Yeah, exactly.
Yeah, same.
Blank screen, blue background.
It was fine until you switched away. So you may have shared.
Does it work now?
No. Just blank screen at the minute.
Let me.
I will stop sharing and then.
Yeah.
We had your slides perfectly, but.
Okay. Is it coming up now?
No.
No.
Oh, that's bad.
Blue screen, a light blue.
Okay, then let me show. I will restart the team session. Sorry for that. 1 second. Yeah.
Yeah, we'll wait.
He seems completely frozen now, but I think he's rejoining.
Yeah, maybe somebody can try to grab the screen first. Maybe this is.
Yeah, I can quickly grab the screen just as a test. So screen. Yeah, lots of clicks. So I should have the screen now.
Yep, you do.
Okay, so that's working. So I will stop sharing. We're sort of expecting Stefan to reappear, but if necessary, I guess we could carry on and then jump back to the workspace demo.
Okay, he's left now, so he might be coming back, if that makes sense.
Just give it a moment.
Yeah, we've still got 11 minutes before we need to move on, so.
Strange.
Whilst we're waiting for him, we had a very successful steering committee meeting last week, so I will be sending you out all emails this afternoon about what features we want you to further develop. So yeah, so look out for that email for this afternoon.
Completely lost it, hasn't he?
Teams doesn't run in AWS. That problem's fixed now, isn't it?
Yeah. I mean, in the interest of time, shall we jump ahead and then maybe come back again? We haven't got a lot of choice if he doesn't reappear.
And the next one is OGC processing.
Yeah. That would be Gerald. Gerald, are you here?
Yes, I'm here. Can you hear me?
Yes.
Yeah, we can. I presume you're picking up the OGC processing section. If you're ready.
Oh, hold on, Stefan. No, that's different, Stefan.
I was waiting for half an hour. I think I was half an hour left, but if you want me to go on, I can do it.
Yes, well, 10:35. So actually, 10 minutes ahead. There was a bit of a juggle in the agenda, to be fair. I mean, if you're ready now, we'll carry on.
I should quit and come back on my computer. It's fine with you.
Right. Okay. You're not ready either. Okay. Perfect.
Can you hear me?
Yes, we can.
Yes.
Sorry, but everybody can hear you also.
Are you ready to go, Gerald?
Okay, let me switch off and come back.
Okay.
Struggling here.
I mean,
yeah, next.
and we could also go down to application quality review. Or Stefan's back. And Gerald's back.
Okay.
Can you hear me now?
Yes.
Okay, yes,
Stefan is.
Nobody can hear you except. Oh, okay.
Stefan is also back. Stefan, can you hear us or not? Stefan, we cannot hear you.
But we can see your screen.
Yes.
Okay. One or the other, I guess. Stefan's leaving again.
Okay. This is getting well. And Gerald's not here anymore?
No, I'm here.
Oh, you're here. Okay. Gerald, can you go for it?
Yeah, I suggest. Carry on, Gerald.
Yes, okay. So I will share my screen.
Yes, please do.
Yeah, go. Yeah, if you can present your building block.
Can you properly see my slide? I will put them in.
Yep.
Like this.
Yep.
So you can hear me okay? Fine.
Yes,
okay.
I can hear you. See your screen.
I will try to be clear during this demonstration, mainly about the versioning of the M chart, because I've heard in the past technical meetings that we were using very old releases of this M chart. So I would like to first point out that the release for the EOEPCA 2.0.0 RC2, release candidate 2, was 0.5.1, and the current release for EOEPCA 2.0.0 release candidate 3 is the Zoo Project DRU M chart version 0.8.2.
Yeah, that's clear to me now. Yeah, thanks, Gerald.
Yeah, I'm sorry, but because we have tried to handle a lot of tasks over this quarter and over the past quarter, but I'm not sure everybody got to the point where we are all using the last test releases and where we are taking advantages of all the development that has been made. So maybe this is why there is some misunderstanding on what was done and what was not done. So what I will present today is, first of all, the Zoo Project Autoscale Zoo FPM pod capability, meaning that we are now able to autoscale the Zoo FPM as we were in the past quarter. But you probably remember that I was afraid about the fact that the Zoo FPM can handle long-running processes, and I was not willing to give any option to anyone to be able to delete this Zoo FPM, which are considered as an important pod because they are taking the responsibility to execute the CWL workflow. So there is no reason, even for an administrator, for being able to remove this pod, even if we have still set up a dedicated notation that you can set on the pod for being able, as an administrator, to force the deletion of this Zoo FPM pod. After that, I will present briefly the Argo workflow fully integrated and consolidated. Then I will show you the upgrade of the Zoo Project DRU Docker image that has passed from Ubuntu 20.04, the LTS, to version 22.04 using Python 3.10. It was actually the first step towards integration of CWL library to replace the current implementation in the deploy service, meaning that even if the CWL to OGC can be using Zoo Python 3.8, we realize that some of its dependencies was relying on Python 3.10. So hopefully we are supporting Python 3.10 now. Then we have also integrated the CWL wrapper in place of the EOL CWL EOAP. We have replaced the old CWL wrapper with the new EOAP CWL wrap in the Zoo Calrissian runner. We have made the validation and testing of the CWL pattern with the current implementation, meaning that we have deployed the last test chart on various platforms, and we have tested the CWL patterns, the 12 CWL pattern, and sometime along the way, we have applied some fixes into the template or in Zoo Calrissian itself. Then we have also made updates to ensure that the Calrissian from the Zoo project DRU behave like the CWL tool, meaning that we are able to enable the bash command from your Docker image, if any, is available in your Docker image. And we have also consolidated the Nux client application. Sorry for the background noise. Then I will briefly go over the ongoing tasks, mainly the aligning Zoo project DRU with the upcoming OGC API processes part 1 core, the next version. So we have made a great announcement, but there is one small task remaining. And then also the provenance review that started during the past quarter and is still ongoing. It's still an ongoing task, and it may be a long-going task. So about the Zoo project autoscale and support for Zoo FPM pod, as I was telling you, we are using KIDA, thanks to Teradue, which pointed out this technology. And to avoid the deletion of the Zoo FPM pod, we are relying on KaiVerno to define a dedicated policy that ensures that nobody can delete the Zoo FPM. On your right-hand side, you can see a screenshot where me, as an administrator, I'm trying to delete the pod manually. And this is the kind of message you will have back, meaning that the Zoo FPM, I don't know if you can read, I can see your eyes switching, Richard. So here is a message you can see when you are trying to delete the pod, meaning that you are not allowed to delete the pod. And in the documentation, as you can see, you can use the emergency delete equal to true, and you annotate your pod with this annotation, and then you will be able to delete the pod manually. So this is completion for the task issue 145. Here is a small demonstration of the auto-scaling capability. I hope you don't see your video on top of my screen, actually.
Gerald,
yeah.
yeah, can you zoom it? I was going to say it's
Yes.
pretty small.
But unfortunately, if I zoom in, I'm not sure I can still move inside the video. So here it is basically starting, right? Once it is started, what you will notice is that the Zoo FPM pod will disappear. Here is the Zoo FPM pod, I think you can see.
Yeah.
Just checking that the video is still playing. Yes, it is. So here you have the RabbitMQ, which is not relying on Bitnami anymore, and which get faster. Accessorily, as a side note, I would say also that the M chart itself for the Zoo project DRU has a lower security issues, because a lot of issues were coming actually from the M chart and led by Bitnami. So here the system has started. We still have the Zoo FPM, but we have also a pod which is responsible to check if any Zoo FPM is currently handling a task. And we have also
Quick question, Gerald.
Yes, go ahead.
The extra services, the KIDA and the Caverno, are they deployed as part of the Zoo Helm chart?
Yes, absolutely. Optionally, you need to activate the KIDA support. You can read the official M chart documentation. Everything should be described there.
Yeah.
So here you have noticed that the Zoo FPM disappeared from the Lens user interface. And now what I will do is that I will deploy a process. So I basically use the usual water body. And then I will start the execution of a job. I pick up the job ID. And if I go here, you can probably see that there is a new Zoo FPM coming. And you can see here on the KEDA operator, the notification that a pod should be created. So fine. After this, you can see also on the background here, the eviction controller, which is setting the number of jobs for every Zoo FPM pod, meaning that you will be able to see on the annotation here, the number of active workers, as you can see. And here I am trying to manually delete this pod, and I get this error message, which is here on purpose. And you can see, as I was saying on the annotation, the number of active workers for every Zoo FPM pod. So then I won't wait for it to complete, right? We know that the water body is running smoothly on Zoo Calrissian. Here you have the scaled object that you can take a look at. If you are deploying it on your own cluster and you face some issue or some stuff like this, you can take a look at the scaled object and get its current status. So here the execution is over. So we are accessing both the status and the result. Okay, fine. So this is not very important because you have seen that multiple times, but what happened behind the scene is that I did not run any other jobs, right? So the Zoo FPM should disappear. And so if I go back here, you can see that there is no Zoo FPM pod anymore, anywhere.
Yeah.
So this was a demonstration for the auto-scaling. I'm sorry that it took so long, but it was more complicated than I was thinking at the beginning of the implementation. So now if we move to the Argo fully integrated and consolidated Argo support. So Argo workflow is fully integrated in the Zoo project DRU Helm chart since version 0.7.0. It means that if you are using any version upper to 0.7.0, you should be able to execute Argo workflow. But I will, as you will see in the next slides, I insist that everybody should use Helm chart Zoo project DRU Helm chart 0.8.0 as the minimum, because we have removed totally the Bitnami dependency, and then you don't have to do any manual modification yourself or pointing to a different Docker image or different Helm chart dependency. So we have, first of all, we have moved the Zoo Argo WF runner under the Zoo project organization. As you can see on the slide, I have noted that it is a clone. So it's I think it's a bit unfortunate, because if the Zoo project is requested to continue managing and updating the source code of Zoo Argo WF runner, maybe it should be the root repository. So maybe the best way will be that we merge the modifications that has been made in this Argo WF runner, specifically under the Zoo project organization. We push it back to the EOEPCA, and then EOEPCA gives the ownership of the repository, right? I don't know, because all the development is currently occurring in this repository.
That makes sense. It does. Yeah, it does make sense. Yes.
Thank you. And I have the same concern for others.
Sorry, I'll just clarify there. If you're saying to make Zoo project be the upstream for this, then I'm in agreement of that for sure.
Okay, great. I was just willing to be sure, and then we will have to interact together to do it. So about the dependencies that are automatically deployed with the consolidated and fully integrated Argo support, we have Argo workflow, Argo event, Prometheus stack, which contain Loki, Grafana, and Prometheus. You have the reference of the issues that has been cleared with this work that has been handled, and you have the documentation on how to enable this. Hopefully, everything is set up automatically for you by the project Helm chart, but sometimes you may face some issue depending on the size, the secret size of the Helm chart, meaning that depending on the other dependencies you are willing to deploy at the exact same time, you may face some issue, but you have the documentation which has been updated to reflect this. So about the Argo fully integrated support, again, I have made a video. I am not sure if it was a requirement, but it took actually a lot of time. Yeah, sorry, and I see you, Richard, again.
Yeah, you can see me straining with my eyes.
Yes, I'm sorry for this. So it's simply starting automatically, right? So you have Argo workflow. So here I did not, I decided to not deploy at the beginning Prometheus local stack. So here it's only Argo workflow. You have, you can define which module, which dependencies you are willing to use. So here we are starting the job as usually. And if we go to the job ID, I can actually I can share with you, Richard, these slides and the slides from the previous quarter, which contains a full-sized video.
Yes.
Because during the previous quarter also I was passing all my videos very quickly, and maybe it was not clear that we accomplished all our task at the time. But
yeah, no, certainly sharing the slides would help.
Okay, so I will share both the slides and the other one. Yeah, they are a bit bigger. They are quite big because they contain the video.
You've got just a time warning and got a few minutes left.
Okay, 5 minutes left.
4, but yeah.
Okay, but okay, so but okay. So I won't show you the Argo workflow support, I guess. So you can see it afterward. As I was mentioning, there may be some issues depending on the number of modules you are willing to activate, and you can face this issue about the M-chart secret size. So in such a case, you can follow the documentation that was integrated in the M-chart documentation. So here it was simply to show that if you activate the Prometheus local stack, you have Grafana, and with Grafana, you have the Zoo project DRU dashboard. And with this dashboard, when you are starting a job execution, you will get the information on this Grafana UI. So we have integrated with Ubuntu 22.04 and Python 3.10. It was done in version 0.6.0. And as a side note, I would like to point out that the community from the Zoo project has also handled the work for supporting the Ubuntu Noble 24.04 using a Python 3.12. And we have made some basic testing of the Zoo project basic setup, and it was working properly. So we also have integrated with CWL to OGC. As you can see in the artifact tab, you can see the release note for every M-chart releases. So you can see that on version 0.7.5, we have this CWL to OGC, both integrated at the same time as the EOEPCWL wrap, which is this one. So as you can note on the bottom left corner, I am wondering also why shouldn't we move the Zoo Calrissian runner under the Zoo project organization upstream? About the validation of the 12 CWL pattern, we have successfully tested them against the Zoo project DRU version 0.8.0. You can see here the basic documentation on how you can run this test on your own. We have basically created from the parameter YML file provided by TerraDue. We have converted this as a JSON execute request for OGC API processes part 1 core. And it is using this request to send request to deploy the patterns and then execute the request using the endpoint you are providing as a parameter. Then, as you know, Richard, we have ensured that the Calrissian behave like CWL tool by detecting the entry point or the base command of Docker image. We have made this with an external service. It was integrated as an optional tooling included in the Zoo project DRU M-chart. So if you are not willing to use this kind of tool, you just need to deactivate, which is a default behavior. So it is not activated per default. But in case you are willing to play with this capability, you can simply activate this option by following the official documentation. So we also have consolidated the Nux client application. You remember probably that the Nux client application was already quite evolved. The only missing part was the fact that when you were executing a process from the execution endpoint, you were not seeing the loading bar immediately, but you were requested to go to the jobs endpoint and to list the job to find your job back, and there you got the loading bar. So this has been cleared, and we have also moved the Zoo project Nux client, which was the old name of the repository, upstream to the Zoo project. So this was the video for the user interface. We are also about the ongoing task. Okay, so I messed up. I messed up with the order of the slide. So about the upcoming task, so maybe I will go this way. So the project DRU and Bitnami is no more dependency. So we removed any container or chart dependencies since version 0.8.0 of the Zoo project DRU and chart. This is why I would like to stress everybody to use at least this version or the next one and the upper one. And in case a new and the upcoming version. About aligning the project DRU with OAPI, OGC API Processes Part 1 Core upcoming version. We have made a lot of work in this field. We are supporting the additional links in the headers, response headers, and also we are including in the headers the profile, meaning that when you are requesting, for example, a job status, you know that the job status you are getting back is profiled as an OGC API processes job status, while it can be any other thing like an openEO job status, for example. We also have the support for the HTTP head method, meaning that you can, for every GET request, for every endpoint which is using the HTTP GET method, the OGC API Processes upcoming version is defining that you should be able to also use the head method. And we got a bit power by defining an option in the Helm chart, which says that you can promote the head method, meaning that for every endpoint in your Open API, you will have the get method and the head method. In case you are developing a website, it can be useful to use only head because you don't need every time the full body and the full response. Sometimes, many times, you can only use information that are returned in the header. And the remaining step is the additional job ID results output ID that I hope to clear over this week or the next week, because I am attending today the OGC code sprint in Rotterdam. Then we have this ongoing task, which is taking a lot of our brain and a lot of our time, we are studying a lot of this. We are willing to integrate Provenance. So you remember that we were working on OGC API Processes Part 4, job management, and we are willing to continue working on this task in the upcoming quarter. And just as a conclusion, I won't add another word, but I want just to point out that the last SM chart of the project DRU is versioned as 0.8.2. This was my last word. Thank you.
Thanks, yeah, and I'll make sure we pick up that latest Helm chart version there, Gerald.
And I will give you the slide. I will send you the slide.
Yeah, that would be useful. Yeah, you've done a lot. You've done a lot there, Gerald. Hard to cram it into 20 minutes, which I appreciate, but good efforts there. You've achieved a lot there, so thanks for that.
Thank you.
In theory, we are due a break in like 2 minutes, but do we want to finish off Stefan's?
Hopefully,
demo?
Yes. That would be good if we've got the technology.
If that is possible, I would appreciate. Yeah. So shall I try share my screen?
Yeah,
again?
please have another go.
You can try and cram it in as quick as you can, but obviously.
Do you see something coming up now?
Give it a second.
Yes.
Yes. No. Perfect. Yeah. Yeah.
We
Sorry
can
for
hear
the
you
trouble.
and see your screen.
Okay, I try to be fast now, and I have prepared in the meantime a few steps. So what I just want to run through now together with you is the quick start for the workspace building block. And what we are trying to achieve here, we try to onboard a new user with his to be able to work on his new idea. And on the right here, you see the different steps. Yeah. So we have Oscar, who is the platform operator. He is creating for this user for Frank. Yeah. So what Frank then subsequently do is he opens his workspace, then he starts the data lab environment. He uses one specific application he needs for his work. Also we chose MLflow in this example. And last but not least, as Frank is not working alone, but also wants to collaborate on data with other teams, with other workspace users. Yeah, he also does some additional setup on how to lay out the storage properly. Yeah. And what I have done now in the meantime is step one. So Oscar, the platform operator here, who is creating a workspace for Frank. So more or less, as you can see on the right side, it's just you get a token via the device flow. So you can see I'm Oscar and I'm an operator. And then it's just a simple HTTP request to the workspace endpoint where I pass the name of Frank. And I'm happy that his workspace is then called WS Frank. Yeah. So this is now I have done that. So in the cluster, if we check ourselves, you can see that we have now a data lab created 70 minutes ago for Frank. and we also have his storage setup done for 70 minutes ago. Yeah? So these steps have been prepared now, and Frank is now able to do his work. The only information he needs is this URL, the Workspace API URL for Frank. Yeah? So this is the thing he needs to open, and then he's directly opening the Workspace dashboard, see his bucket, see credentials to his bucket, see that he's at the moment the only member of his team, and at the moment he only has the default bucket, which is also named like the Workspace. Yeah. But through the management UI, he is then later able to do other things. He can onboard additional members, he can create additional buckets, he can request access to buckets of other workspaces, and if other workspaces request access to his bucket, he's also able to grant it that way. Yeah. So the workspace access is fine. So let's go to the next step. Now I'm opening the data lab. Yeah. What I mean with data lab, so this is a separate a browser window where I have 3 tabs: the terminal, the editor, and the data. So the terminal tab, it's a regular terminal, and just to test that the things are working out of the box, I made a AWS request. You can see there is the bucket, and I copied some dummy data on the bucket, so the data is there now. And the date, so that this test file is here. And also, if you go to the data tab, you can also see that his test file is here. And now let's come to the most interesting part, the VS Code editor. And there it's just a hosted instance. And what I just did is I checked out with Git an example from MLflow, because I just want to verify if the things are working out properly. I did a pip install of the libraries. And now I want to train this specific, also run the training of this specific example. Yeah. But what's important here, I don't want to use the MLflow in my local machine. I want to use the connected Kubernetes cluster to have the MLflow server there visible. So MLflow is a tool on the one hand to track experiment runs. So every time you have a new training run, that's captured there. And also in addition, it captures artifacts you are uploading. So and what this training script is doing, it uploads finally the model as artifact here. So what it should do, it should put this model, which is generated ideally directly on the bucket of Frank in that case. Yeah. So and how can we achieve that? Yeah. At the moment, you can see is it large enough?
Yeah.
So at the moment, you can see in the Kubernetes cluster, which is connected, there's just the core DNS pod running, and I want to deploy now an additional MLflow. Yeah? So we go to the quick start guide. We are here at step 4. In the documentation, there is also an example script on how we can deploy MLflow that way. And as you can see, we are just reusing the credentials from Frank's default bucket. Copy that in here. Deploy that stuff, yeah, and a few seconds later, let's create a separate tab to see it easier. We can see that we have MLflow. It's a great container configuration here. So we don't see that at the moment. What did I do wrong? Is it Frank? I need to investigate that in a second. But the important thing is, if we run the training now, okay, let's use instead not the connected. Let's go back to the example here and to the first step. Let's run the training without additional, just to make the point. Obviously, I missed something of the steps in the meantime, but here that way you can run now the training script with the local MLflow instance. That should come up in a second. And then we should be able to open the integrated MLflow server on that machine here as soon as it's there. And for growth, we go now through we've just followed the quick start steps. Yeah. So here you have the flow aligned. So I'm running the training. then I can see that on my output, I have an MLflow model generated, and this I can now directly browse through the VS Code server instance to this MLflow instance. So it's still hosted. So it's just a click in my data lab environment to open MLflow, and then if I run the training again, yeah, I can see that within MLflow, I can see that the generated model is put into the artifact section of MLflow, and these artifacts, they are really stored in the bucket of Frank. And from there on, he can just share, for example, the model with others via a pre-signed URL. So this is the first way on how Frank can share data with others via pre-signed URLs, but there are other ways. So first of all, we said that we want to have an additional bucket where Bob can stage in data. So what we need to do from Frank's perspective is we just create this bucket for Frank. We create this bucket here, a stage in bucket. And now, as soon as the bucket is here, if we log in as Bob, let's go through the full workflow. So if Bob now wants to connect to this bucket, he can see, show additional buckets. He can see the stage in bucket. This was, as I requested it before, you can see the request already here. Let's also request, perhaps just to test it, we also request the additional Frank bucket. And if we go now back to Frank's perspective, what does he see in the requested bucket session? You can see that Bob on the one hand, he requested access to Frank's bucket, but he also requested access to the stage in bucket. And now, for example, we can say he should have access for the stage in bucket, but we deny access to the main bucket of Bob. Yeah. And if I switch back now one last time to Bob, yeah, we can see that Bob is now able to access the bucket of Frank, as the access was granted, but he is not able to access the stage in bucket, but not as the regular bucket from Frank. Yeah? And this is all reflected in this quick start guide with examples so that you can directly leverage this functionality. And last but not least, as soon as the buckets are provisioned, so we have finally established this setup. We also onboarded Alice to be a part of his team. We can also add Alice here. What does that mean if I do that? So Alice is now a contributor of Frank. So and the nice thing now is if we log in here again with that's the last thing I want to demonstrate now. So Alice, for sure, if we log in with Alice, is able to access her own bucket. She's not able to access Bob's bucket, for example, as Bob badge is also member there, but not for Eric, I guess. Yeah, their access is forbidden. But she is also able now to access Frank's workspace and see the same information as Alice is also member of Frank's team. Yeah, and that way we have closed more or less the loop on how people can collaborate in various ways by inviting people as member, by granting bucket access, or by generating pre-signed URLs. Yeah. Yeah, so sorry for the troubles, and thanks for squeezing me in again. Yeah, so
that's okay. Thanks for well done for recovering there, Stefan. Very quick question from me. The Data Labs instance, I had assumed it was part of the V cluster in the workspace, but then I didn't see the pod, so I guess that isn't the case. How does that fit?
The point is that the Jupyter, also the V cluster Data Lab pod itself, it's running on the host cluster. But it's connecting then either directly to the host cluster to the same namespace in the namespace mode, or it's connecting to a V cluster where the user can manage all his workloads like MLflow and similar. Yeah? What I missed to demonstrate today. And what the documentation also lists another example where we installed Task, for example, in this V cluster instance, the Task Gateway thing, and then you can really do some larger processing which runs then out of process in the task cluster on the V cluster instance and not in the process of the user himself. Yeah? So that are more or less the things we have currently described in the documentation.
And all of that, if we run through that quick start in your documentation, we should cover all of that.
Yes, and obviously perhaps I forgot to delete something, so it did not work reproducible again now. Yeah, but that was my fault. Yeah.
Yeah, no, yeah. I mean, that's very interesting. That quick start is helpful from a deployment and validation point of view, let's say, from my side.
Good.
Okay,
Right.
great. Thanks.
Should we go to a 5-minute break then?
Yeah, so we'll do a break and then we'll pick up with the application hub / Datacube, Fabrice.
Directly to the Datacube then.
Okay.
Yeah, we'll have a break first.
Yeah, fine. Yeah, so 5-minute break and then so 10 past. See you in a sec.
See you on the 5 minutes.
Is everybody back? Are we ready to kick off again?
I know I am.
Yes.
Okay. I suggest Fabrice take it away.
All right. So I will be talking about Datacube, right?
Yes, I wasn't quite sure what your focus would be, so I leave it up to you.
Okay. Let me share my screen. All right, here we go. Well, yes, our activities in the Datacube end up by creating a second use case. So the first one was presented earlier this morning. This one is built on top of something that we already had worked on, which is SCWL and the ZAR Cloud Native format. So we already had an application package that would read a few cogs, and the output instead of being a GeoTIFF described by a stack item would be a ZAR store. Okay, a ZAR V2 for as a side note. What we have done in this quarter is to extend how this first application package worked. Let's call it the producer application package, because in the end, this one reads does a query to a stack API, processes water bodies, detects water bodies for each of the acquisitions, and so technically we get a Datacube of detected water bodies over time in a given area. The output is a ZAR store. It is described with stack, and so we definitely see that we will have to work again on this item to accommodate the decisions and the discussions that happened last week in Rome about the stack and ZAR. So there is discussions about bands, variables, and so on and so forth. So we have to review that. I have learned a lot about the ZAR V2 versus V3 and all the discussions around the EOPF ZAR and the format and the extensions. Well, in the ZAR world, we have to call them conventions that development seed is working on to include overviews in a ZAR Cloud Native format output. So in the ZAR store, you would have technically have overviews of your data. So I would have overviews of the detected water bodies at different resolutions. And this is important because it would then guarantee an easy visualization via ttyler or xpublish or something like that. So that would definitely help. So this is work that we have to do on top of the producer application. And then what we have done extending this solution with a consumer application package. And this is an application package that will actually read the ZAR store that was created by the producer application package and do some aggregations over time to detect where the water bodies is most frequent. So we get a kind of percentage of observed water bodies over time. So this is a very simple application, but yet it really shows a flow between producing a ZAR store and then consuming the ZAR store. So this is part of your usual e-learning modules that can be self-procured or either consumed via the NOR, and we do trainings around that. So there is, let's say, too long do not read introduction about what is happening here. So it shows all the functioning of and the diagrams of the producer application package. And if we scroll down, we have the rest of the information. Then we have description of the consumer application package. Here we go, how it works, and we get an execution demonstration of what happens here. Let me scroll down. Well, this is the stack item and the collection with the water bodies detected. And then if we go down, I guess we get a nice image. Well, this is the water bodies detected at a given slice in time. And then the part 4 is to consume the ZAR store. And in the end, you see the aggregation. This is what we have in terms of result of the consumer application package. So the important message here is that we do have to look into ZAR as to support ZAR in its full extent. And so we have done that by carrying this work in terms of describing an application package that would produce, an application package that would consume. We have extended CalRecent to support procuring Dask resources to better work with Xarray with ZAR, so that we have good performance in terms of being able to split the work into Dask workers, and that all happening with CalRecent. So technically, an application package that wants to do this and scale up to large areas or large Datacube as inputs with many observations can rely on the CalRecent to get a Dask cluster to help share the work around the worker nodes. So this is the update that we have on this topic, Richard.
Okay,
happy to
thanks.
take any questions.
So a couple from me. So the application package has a requirement on Dask. Is that, I guess, what I've inferred from what you've described there?
Not this one. This one runs without Dask. What we have done is that we have dedicated a module here. Let me duplicate that. We have another one that relies on Dask. So if we look at we have one that processes EOPF Sentinel-2, and you see that at some stage we have here a Dask gateway requirement managed by CalRecent. Let me zoom in a bit. Okay, here we go.
Yeah, no, perfect. Yeah, I've got that. Okay, thanks. Gunther, you have your hand up?
Yeah, thank you, Fabrice. This was very interesting. Just for my curiosity, I mean, your consumer and producer examples here, is this the good examples that we have to promote to the science and the value adder community on how they should read and produce data in future?
Not at this stage, and let me tell you why. Because there is a lot of discussion around the OGC GeoZAR, and at this stage, it's not really consolidated yet, and the discussions have been carrying on a lot. What we had discussed with Emmanuel from Development Seed is that we will try the bottom-up approach, let's say, based on the work that is being done on the OPF ZAR for Sentinel-1, 2, and 3. The technical choices and the conventions that are adopted in that context, the goal is to push them up and say, okay, this is the way forward if you want to adopt ZAR in our context. But the message that we can say to the community is that if they are working with 2D data, well, typically observation data fits very well in this context. You produce an NDVI, then it becomes a technical choice whether you go for ZAR or for COG. If you ramp up in dimensions and you start producing hypercubes, then at that level, it makes a lot of sense to use ZAR, and the ZAR community is really active in that domain. The thing is that we still miss a standardization effort around what is for us a GeoZAR, what is a ZAR that includes stack metadata, a ZAR that is clear on how the projection information is there, a ZAR that is clear on how the overviews are declared and things like that. But there is a lot of work ongoing that domain.
So it's a question of maturity, but let's say it's the vision that we push long term.
Yes. But anyway, ESA is pushing really hard with the EOPF initiative, so the community will have to jump on board, and this is why this work is being done here at the application package level, to see how to produce the ZAR and to consume ZAR source.
Okay, thank you.
Thank you.
Sorry, just Salvatore, I think we should share that maybe at the next DCB.
Yes.
Okay.
Yeah.
Yes, yes. This is something we should point. Yes. I get it.
And another question from me, Fabrice. Where I guess these are cloud natives. So does that mean you're essentially bypassing any staging type behavior in the application package? You're going directly to the data.
Well, yes, that is the goal. Yes, by ZAR being cloud native, it is that it expresses the fact that the ZAR store is either exposed by S3 or exposed via an HTTP, which in the end is pretty much the same in the end. But the fact is that you actually don't stage the ZAR store. You just cherry pick whatever you need. This is definitely the way forward at that level. But let's be honest. The cloud optimized GeoTIFF is also cloud native format.
Mm-hmm.
There was no real mandate in staging COGS. Although sometimes it is a trade-off. It's maybe cheaper to download if you do a lot of accesses, and it's too expensive if you do some NDVI. Well, you need a small chunk of the data, so that is a trade-off.
So what do you pass as an input then to the application package? Just a URL to the stack or something?
It's always a stack item with an asset that points to the ZAR store.
Yeah.
It has its MIME type. It has everything for the application to understand. And the work that was done in Rome also helps to understand the structure of the ZAR data. So for instance, when you process EOPF data, there is now a transparent approach to get the red band at 10 meters. So it's way more explicit in that level. So you don't have to write a notebook with Xarray to explore the ZAR store to understand how the data is structured. The stack item itself carries the information for you to understand what you have to consume. So it automates the transition between the stack item and the Xarray code. So that is a good outcome from Rome.
Understood. Okay. Thanks, Fabrice. Any more on that, or should we move on?
No, carry on, move on. Thank you.
Okay, thank you, Fabrice. So up next would be Vito, Eurac, around openEO, federated orchestrator. Stefan?
Okay, yes, thank you. Good morning. See if I can share my screen.
You've got 20 minutes as well.
Okay, I assume you see my screen now. So yeah, I'm going to report on the work from Vito we did on mainly openEO components. So I have a couple of topics to discuss. I'll start with a Python version upgrade, which was most of our activity in the cycle, and also talk a bit about the CWL integration, load stack support, and then some smaller topics at the end. So first I'll start with the Python version update. So we briefly touched on that in the previous cycle, but now did a lot of work on that. So there the main focus was to upgrade a couple of openEO backend components because these date back from the days when Python 3.8 was like the latest, newest. But yeah, time has changed. So we were forced to upgrade a bit because we had issues with dependencies who were getting pretty old. So we decided to jump from Python 3.8 to Python 3.11. So 3 versions. In principle, because we implement the openEO API, that should not have a user-facing impact, except for UDFs, of course, which are, in our case, Python-based. So there you have a big impact from that update, mainly because of UDF dependencies, where users depend on certain packages they want in their environment. So it's not only version upgrades that happen there, but also some dropped dependencies because we want to to manage the size of our Docker images. So there's also some concern there. Because this is a user-facing change, we did a phased rollout of this migration. And at the moment, we're in the phase where openEO batch jobs run by default in a Python 3.11 environment. So simple.
Are you changing slides, Stefan? Because we are still seeing the starting slide.
Oh, you're not seeing?
No, sorry.
Okay, I'll try to.
Oh, yeah, we saw it there for a second.
So you saw this slide?
So we see the front side, yes. Yeah.
We're seeing the title slide, yes.
Okay, then I won't show.
We can see your PowerPoint now if you don't put it in presentation mode.
Yeah, I'll do it like that then.
Yeah, that's fine.
That's good. Where was I? Yeah, I was explaining this. So yeah, I was talking about the phased rollout. So yeah, at the moment we're in the phase where batch jobs by default run in a Python 3.11 environment, except when users use UDFs, we stick to the Python 3.8 environment to not break existing workflows. Regardless of that, users can still explicitly select a desired environment through picking the runtime version, which is a standard openEO feature where you can select a particular version of your runtime environment, or which is a bit custom to the Vito implementation. You can also have an explicit image name job option when you create your job, where you can specify, and this is basic. This Python 3.11 is an alias for a long form Docker image reference. But this way, users can select on a per job basis for a particular environment they want to run their job in. The upgrade from 3.8 to 3.11 was quite more work, more involved, more complex than we anticipated initially. There are both challenges at the user side, so the UDF aspect of the user side, and also some operational challenges we had to tackle. A large reason of that is it's a complex web of related and coupled updates. For example, we went from NumPy 1 to 2, from Pandas, we went also to version 2. We also had an X-ray update. Also the Spark and the PySpark version got an update, and that also resulted in some updates we had to do on the Scala part, which was also a bit breaking, also a Java update. And unfortunately, we could not fully decouple all these updates, so it was a very large step we had to take. So that was a lot of wrestling with build pipelines, Docker images, all that kind of stuff. And we had to also take into account to support both versions in parallel, so users can still pick what they want. So it was quite a challenging endeavor, which is still going on, and consumed a lot of our time in this cycle and pushed back on the other activities a bit. But I think that concludes the slides about the Python version update. Then next up is the CWL integration. So like in the previous cycles, the Cloud Insula use case is the main driver for development on that part, also testing it, test driving, improving the maturity, making things operational and these kind of things. So some new developments is provisioning of credentials in the CWL container for S3 access. We had to do for Cloud Insula to access particular data sets there within the CWL processes. We did some general maturity improvements related to cleanup of resources that were just temporarily things, some namespace management. And we are also in development and testing phase of improved S3 integration of the load stack phase, which is a phase practically after the CWL, where we have to go from the CWL representation of data to the openEO way of representing data. So we have a load stack there in between. We improved there the S3 integration. We also are experimenting with parallelization of the processing at the CWL level to scale up some use cases. And we worked also some on the write many issues, debugging some things there when issues pop up. And then as an illustration of the CWL integration, again from the Cloud Insar use case, we have here an example of this custom process Insar interferogram snapu, which can be run with standard openEO tooling, and under the hood, the CWL process is handled by Calrissian, as discussed before. And then on the right side of the slide, you can see the outputs that it generates of interferograms that are produced from such an example run. Then next up is the stack and the load stack support improvements. There we're working on a big internal refactor of the load stack implementation to enable more future evolution, broader stack support, and easier maintenance, and make it possible to more feature support more features, and do bug fixes, of course. And there we're largely driven by use cases that are hammering our load stack implementation. So we have a lot of internal and external use cases that depend on load stack and provide us with a lot of input and feedback on the implementation. So on the right side, you see a couple of tickets we have handled that way during this cycle. Then next up is a smaller thing about the federation extension support, which was mostly work done in the previous cycle, but we did some more improvements there with regards to the property about which backend support a certain feature. So in this case, we added that for the UDF runtimes, which you can see here on the right, visualized in the web editor. Also, secondary services is covered there as well. Another thing about the federation component, or the aggregator, as we call it sometimes, now these packages are published on the standard PyPI index, which avoids some annoying extra URLs you had to provide when you wanted to install these projects, which makes it a bit easier to get a working installation of this component. Then another thing we worked on is the support for the processing parameters, which is like an extension in openEO, where a backend can define a large set of special parameters or batch job related parameters, processing related parameters, and that can now be visualized in the web editor. So we added support for that on the openEO here Travis backend. And now when users create a job, they can, as you can see on the right side here, users can specify a large list of options to fine tune how their job will run on the backend. And then the final thing I wanted to mention is for the openEO GeoPySpark implementation. We had a non-trivial contribution by Hannes from Brockman Consult. I don't know the exact details, but it's related to a resampling method for Sentinel-3 collection loading. So he managed to run the backend locally and develop this feature on the actual GeoPySpark repository, and managed to get a PR and get that merged in the project. So that's also an illustration that the GeoPySpark driver implementation is also relevant outside of just Vito. And I think, that concludes the slides I wanted to show here.
Thanks, Stefan. I had a quick question. You showed us the function Datacube from process. I presume that's the process for invoking the application package.
Well, that's actually the a generic helper to run any openEO process. So, and that openEO process is a wrapper for the CWL details. But this process ID, instar, interferogram, that's the openEO level name of that process. Yes.
So how? Therefore, my question is, how does the CWL, if you like, get introduced into the back end essentially for execution?
So at the moment, that's indeed hard coded, you could say. So we have custom wrappers for each CWL use case we want to support. So we have to provide custom written wrappers. Of course, we want to automate that better to have some more standard way of allowing this. But in this phase, we're still doing that with custom wrappers.
Okay. So you could imagine a future where the CWL becomes a parameter effectively in
that's a long-term goal, of course. Yes.
Yeah. Okay. Thanks.
Okay.
No more questions. Thank you. I don't know if since we're talking openEO, I don't know if Eurac, you had any comment on the work you're doing. Okay.
Yes, we have some quick updates and short demos. Okay, so our main task in the processing building block were to set up the openEO Argo workflows, which uses the openEO processes Dask implementation into the dev cluster. There has been quite a significant setback with the Bitnami chart situation. It was took a lot longer to fix than expected, and it's still not quite there, but I will show that in a little bit. And then in the processes Dask itself, what my colleague Eurac will show in a little bit is we have implemented the native UDF support in the backend itself. So before it was kind of using the Python client implementation, but now it is fully in the backend, which also fixed some other issues that were related to UDF, such as the dimension names, which were not passed in the UDF. And before the demonstration, so for the next activities, we would also like to migrate the openEO processes Dask to NumPy 2.0. We would like to create containerized openEO clients. So one which will use the sort of local processing functionality, which doesn't require a backend connection, so that can be run fully locally by a user, and one which will allow the user to connect to a specific backend. Since now, in a while, hopefully we'll get the Argo workflows running. We would like to begin the CWL process implementation now that we have a Kubernetes deployment of that. So using the Calrissian to kind of align also with the work that Vito is doing. And in general, there's still quite a bit of maintenance and fixing required to get this running. And thank you, Richard, for supporting this. So with that said, can now see that we have attempted to make a deployment, but there are still a couple of issues which need a little bit of examination. But I think we're on a good track to have something actually fully working in a little bit. And so then I would like to hand over to my colleague Eurac to quickly show the UDF implementation.
Yeah, thank you, Eurac. I'll just share my screen. Okay, so can you guys see my screen?
Yeah.
Yes.
Yeah, so as Eurac already said, we are implementing the openEO processor task UDF functions locally. So this is the notebook which demonstrates how it works. So I'm just gonna run it for you quickly. So you can see it's loading the all these things from locally. It's my local setup for this openEO processor task. So it's loaded this, and then we are defining UDF, and then we are testing our corrected fix for local implementation. So you can see the semantic names are preserved. So it doesn't give you like dim_0, dim_1 kind of thing. It gives the actual names of dimensions. Then like different combinations with apply dimension, we fix a little bit in apply dimension also, so that it works perfectly with the local flow of it. So again, you can see it's preserving the dimensions. And it's a full integration, so you can see it's working perfectly fine. Yeah. So yeah, that's a quick demo about this local time implementation of UDFs.
Thank you.
Thank you very much. Any questions?
I mean,
Don't know
just
how
as
much
comment, I mean,
time.
the local implementation means that it's running with the X-array task components, which could then later also be utilized in the deployment of this, of course.
Of course, yeah.
So that there's not a confusion about this.
Okay. Thank you, guys. I'll stop sharing. Thank you very much for your time.
Thank you.
Just maybe quickly, this was using a local apply ufunc then? Like it's really doing chunking over the Datacube?
Okay. Supposedly it's doing that because it's all local. Nothing is using Python client here.
Yeah.
Yeah.
Yeah, it's an interesting feature. This is something we were missing in the local connection, so interesting to see when it arrives.
Yeah, sure. It's still in PR, so I need to get reviewed properly, and maybe some changes here and there. Then yeah, let's see. Thank you.
Richard, there's a question in the chat from Matthias. He also had some progress, but I'm just conscious of time.
How are we doing for time?
Yeah, in theory, we should move on to the next slot, but I didn't want to preclude Matthias from.
I can't see the question, so.
Mentioned.
He just asked if he should report on progress. So yes, I guess is the answer.
Yeah, not sure. I'm not getting that. Okay. Yeah, I can't see the question, so I don't know what's happened there, but never mind.
Yeah, Matthias, if you could just be quick, sorry.
Sure. Yeah, I can. Keep sharing the screen. So yeah, one thing that, Stefan already mentioned that to a bit. In the web editor, we have this new functionality to, like, when you create a batch job or synchronous or web service functionality, you can add these advanced parameters for processing now, right? So that number of cores, memory, and so on, whatever custom functionality you have can now be set in the web editor, edited, and be visualized. In addition, we had major tasks on API and specification development this quarter. One of them is migrating the openEO specific tokens to JSON Web Tokens. There is a PR for that open. I think most of the issues in that PR are solved. It's not merged yet, but plan to be merged soon. We just need to resolve a couple of last minute feedback that we got in that PR. And similarly, one task was to update the process and API specifications. We have a long project board here with a lot of solved issues during the quarter. Some of them were solved before, but most of them were solved this quarter. A couple of open ones where there is still feedback from the community that needs to be resolved, but it's not a lot of issues here for processes. And the same thing for the API, where we have a number of issues solved, a couple of small ones open still. So that's open for the next month to be resolved, and then we get these new versions released out to the world, and especially this token issue should help aligning with the OGC API processes specification, as well making it easier to authenticate with the web editor and other tooling in the future. I hope that was quick enough.
Yeah, thanks for that.
Thank you. Yeah, Richard's just checking that the recording is working on your side, because Fabrice said it stopped working on his side, but it's working for me. So I just wanted to check it's working for you.
It's still saying recording.
Okay, perfect. Just wanted to double check.
It does at some point. It's got some time limit, so it will at some point.
Oh, okay, that might be what it is.
Do a sort of part 2 essentially, but that's seamless. It should be.
Okay. All right.
Next,
crossed,
anyway.
Yeah, next is notification automation. So, Marian, you've got 20 minutes in theory.
Thank you. Just started the timer. Okay, let me share my screen. I have just a few slides, and I hope you can see it. Hopefully.
Yep.
Yeah, if you just go to the next one to check we can see the next slide.
Yeah. Okay, so I reduced the number of slides to have more time for the demo, as I plan to do it live. If not, then prepared the video yesterday. So hopefully it's going to be okay. So I'm going to present the things that have changed since the last demo. So I'll skip the introduction of the building block. Most of you are aware of it. So since the last demo, what do we have? So based on support from the other building blocks, we have several things working. One of them was presented by Gerard some time ago. It was the Zoom integration, at least the notification part, so consuming notifications from Zoom. That was developed at that point. And then one of the great things that happened is that we got support in EOEPCA. So this fits several use cases, and one of them will be presented now. So this is one of the things I'm extremely happy to have it available. So support for the notification API in EOEPCA, basically. This was done by development seed by Felix mostly. And there are other components which are going to be demoed today. So basically, we are going to provide other, let's say, notification sources. One of them are notifications issues by the orchestration system by Kubernetes itself. So the API server integration. This was not planned to be demoed, but I noticed that the developer cluster is working properly, so we're going to do it. And some simple automation, some, let's say, candy like Slack integration. Also, we added support for serverless functions. This is not going to be added until we get let's say we get proper support upstream. There are some changes downstream, and also we simplify the deployment by removing custom Helm charts which we had previously. Okay, so the next step, it's more direct integration with other building blocks. One of them is the resource registration, so this is going to be one of the focuses for the next period. There was some initial discussions with Tom and Angelos in Riga a few weeks ago. So basically that's going to be related to the PubSub cloud event encapsulation. So how to handle it, let's say, in a transparent way. And we also plan on more active integration with the processing building block. So not just consuming, but also interacting with it. And there are outstanding issues, and this is, and I apologize because I didn't mention the resource health part was integrated up to the point of integration with the authentication system. If maybe some of you recall the fact that it was raised by our colleagues, the fact that by the resource cell building block, the fact that they run untrusted code, and this raised at that point authentication authorization issues. That's not yet not fixed. Basically, we are waiting a bit until we fix one of the primary issues that's related to the development cluster, particularly the version. And from what we discussed together with Richard, that's going to happen soon in the next weeks. But that's basically that will unblock a few of the steps.
Yeah,
Okay,
very quickly, Marion. That the intention is to do that immediately after this demo, essentially. And from research, it looks like a low risk upgrade for all of the building blocks, but we just didn't want to do it before the demo.
Yeah, I will be also tested this. I'm going to stop sharing the slides now, and I'll share the screen. I ask you for a bit of patience until I move the windows around. It's more elaborate setup. Okay, hopefully this one. So what do we plan to demo now? So basically it's not completely end-to-end because it doesn't trigger any, let's say, processing, but it crosses a few of the building blocks, what we plan to demonstrate now. So particularly, we want to demonstrate the whole, let's say, resource registration integration with EOEPCA, with the notification system, and then to an automation. In this case, the automation, it's an automation which forwards the messages, the cloud events, as is to Slack, to the one, basically a Slack on the a Slack channel on the Slack instance used by us. If you are curious, it's Richard set up this some time ago, is the notification automation events channel. Okay, 1 second to prepare my notes. So basically, what we have now, we have, if you have a look, we have in the there are some components developed by development seeds. So particularly in the data access component, in the data access namespace, we have the component, basically in our terminology, it's called the sync binding. It's deployed using their Helm chart. Basically, it's the EOEPCA notifier component. This one, it's instructed to forward events to let's call it the primary broker in the cluster. Okay, so this happens already. It's happening. In case there are events, they are sent even now to this endpoint. Okay, so this is one of them, and then we have some let's say some services deployed. In the current namespace, we have the event display, which is the one I'm going to use now, event display service. This is a serverless service, so basically it's scaled up and down automatically by the serverless component. In this setup, in order for everything to work as smooth as possible, it has a mean scale of 1. That's the reason why it's running basically now. If you do a kube control get pods, we should be able to see the service, and also there is another application again, serverless application, which basically represents the automation. This is a component which whose whole responsibility is to send messages to the configured channel. Okay, so this is just to introduce, and let me check the time. Okay, okay, so basically this is the backend setup. We have the broker. We can use the Knative command line, like for example, broker list. We see the broker called primary. This is the, let's say, fully qualified domain name, which we are not going to use. So we are going to use local discovery. Okay, so first of all, I'm going to create a new trigger. So Knative trigger, I want to create a new trigger which sends all messages to the event display service. In the lower window, I'm going to show the standard output. This is until we get the logging facility. So now I'm going to create the trigger. Basically, this trigger will reference the broker. So the broker is called primary and it's in the current namespace. So this is optional, specifying the namespace, and then we have to specify the destination sink. The destination sink for this will be K service, and it was called event display. After we do this, we have also to give it a name. Let's say send all to event display. At this point, we have the trigger defined. So PM trigger is okay. The trigger is defined. Now, if events get generated, they are displayed automatically on the. They are displayed by the event display service. For demo purposes, until I prepare the rest, we can enable. It was disabled now. We can enable the. We can enable, let's say, the event source directly from Kubernetes. In a few seconds, you are going to see messages flowing to the event window behind, hopefully. Okay, and in the meantime, we are going to send to register a new process. And before doing that, so this is, if you look at the, this is the registration API, the one that Angelos presented. Okay, now we also see events from Kubernetes arriving. So these are various events unrelated to the demo itself. It was just to show how it can be integrated with the whole platform. So in this example, we see changes to crossplane, to like basically any component that is created, updated, or deleted inside Kubernetes. So this was just for, let's say, showing the functionality. I'm going to disable this in order to, let's say, have silence for the rest of the notifications. Okay, so now the step is to go to the registration API and where is it? Register, okay. So I'm going to copy paste now and register a new collection. Okay. Second, so we have a new collection. Try it out. So we are using the registration API. Okay, let's call it, I don't know, Q3 demo, for example. I have to remember this. Okay, before proceeding, we are going to create KN trigger, create a new trigger. This one is going to be applied again to the primary broker. The destination sink is going to be not this one, so it's going to be the EOEPCA to Slack service. So we are going to create this new trigger, which sends to the K service called EOEPCA to Slack in the notification automation namespace. And we are going to do different. We are going to add a filter which specifies the collection. In this example, is going to be collection, and you will see why it matters. So this is the collection, and the name of the collection, I don't remember it. It was Q3 demo, I think so. Huh? Yeah. Send Q3 demo events to Slack. Okay. So let's see if it's ready. And trigger this. So we have this one ready, sending some of the messages to Slack, to the automation, which in turn sends to Slack. Okay, so we have the collection created. The response was 200. No? I think so. I didn't, yeah, it finished. And now I'm going to return and do the same call again. Not the same call, but register an item. So we have, we register a new item using the registration API. Okay, so this is the item and it's going to go to the Q3 demo collection. Okay, let's call the execute. It takes some time. You can also see the, you can, it happened already. We received some messages from to Slack, so they've been sent. Let's, okay. So this is the insert of the Q3 demo, which was sent previously. So we send the request to registration API, which in turn discussed with EOEPCA, so basically with PG step, which in turn interacted with the notifier component, which sent to the, basically to the event mesh, which sent the final message to the Slack client. Okay. So basically, this is what happened. Okay, so this was to show the whole interaction between the user using the registration API, the data access building block, the notification building block, and finally the automation part of it, which resulted in data being sent to a third-party application. In this case, how it's called, in this case, Slack.
Excellent, thanks, Marian. So just so I understand the architecture here, so the broker is receiving the events, but that relies on triggers to actually effectively listen, if you like, on relevant events and do something useful with them.
Yeah, exactly.
Yeah. Okay. And so in this example, the trigger was designed to do the Slack integration in this particular case.
Yeah. So, for example, now if I recreate the trigger, and maybe until we continue with the discussion, trigger delete, we'll see messages from the harvester coming. Okay, and let's create it without the filter. What happened, and this is and because I forgot about it, basically the filter filters based on the attributes. So this one, and EOEPCA adds an attribute which is called collection. In this example is the collection to which the item was added. It was Q3 demo, and the filter, the one that I'm going to delete now, the one that I'm selecting, is filtering based on these attributes. This is the simple type of filters. There are also SQL-like filters which you can use to apply more, let's say, elaborate conditional stuff. Okay, so now if I do this, and maybe while we continue discussion, if you are lucky, we are going to see lots of events flowing around.
Okay, because now you're just going to get every single message that happens to go into that broker.
Yeah.
And you've wired up. You were getting Kubernetes events, I think we saw. So you've somehow wired Kubernetes to.
Yeah, that's a native functionality. I disable it because it tends to produce an event, but the way I configure it, it produces events based on anything, so any change. But that can be, for example, we can specify which are the, so this is the type of sync, it's called API server source. And in this example, it matches all namespaces basically, because all namespaces have this. And it matches the event objects in Kubernetes, so basically events, and they are dispatched to the primary broker. But based on other conditions, there are also event selectors, so we can, for example, we can consume events which are marked as being part of or generated by a EOEPCA building block, for example, so to ignore the rest of them.
Yeah.
But for example, it's I was watching while Stefan was presenting. You can see like Workspace is spinning up and down and things like this. So that's
so we can see a pathway for each building block where relevant, at least, to contribute, if you like, their events into this approach.
Yeah. So this, for example, this is a Kubernetes event, and what it contains. Basically, of most importance is the involved object properties. So these are standard properties from Kubernetes and specifies which is the object to which it applies. In this example, it was an internal component, but if you scroll up, you will see also EOEPCA stuff, cross-playing and so on. So, but it tends to produce lots of events. So that's why
I can imagine. Yeah.
I was just about to say, time is up. Thank you, Marion.
Thanks a lot, Marion. Yeah, starting to come together now, isn't it? And I think we can see the framework that's now there, that the other building blocks can follow the lead of the. I guess we've got two now so far. We've got Zoo, we've got EOAPI, so others can start to build in support for this. Yeah, sorry, Marion, go ahead.
There is also resource health. It was the first one.
Yes.
Yeah,
that's blocked due to limitations in the what we can provide.
Yeah.
Okay. Blazer, are you okay to ask your question in the chat, just because we're already running behind unless it's something you wanted to address?
Okay.
Okay, thank you. Marion, if you just look at the chat. Right, CS group next with MLOps and Data Gateway. So you've got 15 minutes for each.
Yes. Hello.
Hi, Clément.
Hang on, everyone. 1 hour left.
Yeah, thanks, everyone.
I'll share my screen. Is it? Okay.
We can see it. And yeah, I'll let you know. Just go to the next slide so we can check that it works.
Okay. So today we're going to talk about the fixed work order of the MLOps building blocks. There was two main tasks in this work order. It's two remaining technical activities with a remote machine learning training with a processing building block, and the publication of a project, so model data set, in the resource catalog. I've also added a line about a task in the last work order because it wasn't finalized at the moment of the demo, so I will give a few informations about it because it was finalized at the start of this work order. But first, just to share a few information about the deployment. While working on the work order, I noticed a few bugs. So we did bug fixes and we released a new version with a patch. The current image was published and the development cluster was updated with it. So everything should be up to date. Now about the task I talked about with the industrialization of the CWL EOAP tool. I think it was fifth work order. I showed for the model inference a tool where there was two features to conform to EOAP best practices. One, for people that didn't know too much about stack, the idea being that in the processing, the input is stack for files,
and the output should be also in a stack format. But scientists don't know for sure this format. So the idea was to have a tool that could take a stack input and just dump the assets as simple files for the next processing that will be written by the scientist, and a command that could generate a catalog from files or a directory of resources that will be output by the process. In addition to this one, I've also added a new feature in the work order 6 with the ability to download sharing up datasets that will come in handy in the training that I will show later. So this tool was mostly implemented in the last work order, but we were waiting for the at CS Group. We have an open source programming office that handle all open source related stuff, and so I had to submit a document to have the permission to release publicly the tool. The process was finished, and you can see here the URL of the tool. It also have a Docker image that is used in the SOBL, and so is also used can be used in the processing building block. Of course, because these tools are meant to be used in processes, there are suitable examples with a command line tool for each command. So for the first task that we present, there is the subject of the publication of our project in the resource catalog. First, I've put a little bullet points for the context. Sharing Hub provide natively a Stack API where model and dataset repositories in GitLab are automatically translated to Stack formats, meaning that you have a Stack API with already the model and datasets. The MLflow model registry is integrated, so if you have registered in this model registry a version of your model, it will be available in the stack of the model. And metadata can be customized by the user through YAML in the repository, meaning you can add the extensions you need. So for the steps that we established after a meeting, there was the update of the model I used for the past demonstrations to use the MLM stack extension. It's a machine learning model stack extension to describe a model. And then Angelas tested if he could register the model via the registration API. It demonstrated it 2 hours ago, if I remember. So we could check that it worked. And so we are, for the last part, waiting for the Stack API harvester implementation, because as I know now, the Stack harvester only works with static catalogs, and we talked about the ability for it to work with Stack API, which is dynamic. So this is it for the publication part. The conclusion is that for now it works manually, that you can register your models with codes. There are demonstration notebooks in the resource catalog with a registration API. Next is the main part, demonstration of the remote ML training. I will use the same model and dataset I used previously. So a flood model that does image segmentation to show flooded areas. We won't we won't see too much about this because it's not the subject. So training being, well, it takes time. I did a record to show and skip the waiting time. I think. No. So this is a notebook I prepared. At the start here, you can see a few informations that are present in other demonstration notebooks for EOEPCA with variables for the authentication, the domain to target the development cluster, and such things. So this is just a few preparations here. Here we have the code that you can also see in other notebooks to authenticate with the IAM, where we drive a token. Right here, I won't go too much into details, but this is just a simple process climbing class I did that just post and things that needs to have nicer calls to upload it to call the API. And now we are at the main part, the process itself, which is defined in a CDWL file. You can see it here. Here it's a demo focused file because I did develop a more generic process, but there are more inputs in it. So I pre-configured a demonstration CDWL file to have less inputs and to be easier in the demo. Here's a little code to show that we extracted the name of the process that will be in the process building block then. And here is an image to represent the process. I will just simply describe it that it's a few steps. As you can see, there is a prepare dataset step here. The idea being that ensuring datasets are Git repositories that are configured with DVC, data version control, that uses S3 buckets as a remote storage. So we have this node that clone the dataset repository, configure the credentials for the access, and it can pull the data already. But here we don't want to pull it in this step because we will be streaming them in the training to avoid pulling all the data set and having it in the local file system in the training. And just after that, there is of course training itself that have a few its own arguments. So here we have learning rate, so parameter for the model, and we also have MLflow experiment because the training logs into MLflow sharing hub the metrics and the artifacts. And finally, we have the stack catalog right here that takes the output ONNX file and catalog it for stack to be compliant with best practices. I think I'm missing a lot of time and we'll go a little faster. So right here, we listed the process where we don't have our process. So we registered right here. We do have the OGC API processes response right here that shows the process with the inputs, the outputs. And now we go to the training right here. I just demonstrated that can inspect the inputs in the process. A little detail here. So we have the parameters, actual MLflow configuration. So dataset version being a Git reference for the dataset repository, and here a few configuration to pull to clone the repository, and after that the workspace credentials because as I said it's everything stored in the workspace. So right here we do then execute the process, and then we have a little monitoring code that will go over each 10 seconds to see the updates. We are going to skip a little. Just I think it's right here. Yes, the training has started in the monitoring. So I'm going to MLflow, and we can see that that training run was created. So the training is progressing. Then I think we can go a few minutes. It's training, and then right here the training was completed. So we have the successful training with the result location, the logs being available through Zoo, and then we can go into MLflow right here, and after refresh we see that the runs was successful, and we can go in the run itself, and we can see the log model where we can download it. And we have of course the parameters and the metrics. And that's it for the training. I took a little too much time. So for the final activities in the next work order, we will we'll provide support if there is any problem for the 2.0 release, and we will focus on using the remaining budget to document everything and to produce a demonstration video where we will try to go over all of the use cases.
Thanks. Good. That's a nice demo. Very quick question. Where is the storage for the model artifacts that then are registered in MLflow? Where does that go?
It's an S3 bucket configured in the MLflow deployment. So it's a pre-configured bucket.
Okay, and the training has direct access to that bucket essentially.
The training logs with the MLflow API, and then MLflow does store it where it's configured to.
Okay, understood. Okay, thank you.
I will.
Don't know how we're doing for time.
I will hand over to Sylvain.
Yeah, we're fine. Yes, Sylvain, you've got 15 minutes.
Yes. Hello, everyone. So I will share my screen. Is it okay? Do you see it?
Yes.
Yeah.
Yeah, thanks. So I will present you the big features that were developed during the past quarter on the data gateway building block, which is EODAG. So the first one is the replacement of the standard we used, that was open search extension for Earth observation, that was used for metadata representation, and that is now replaced with Stack. And so this impacts both the API and the search result representation. And the other main feature that was developed was the addition of a new provider to access CCI open data, and that is called Vito SIDA. So first, we will see the highlights of the stack formatted API results feature. So this feature is now available in a new version of EODAG, the version 4.0 Alpha 1. All the changes are documented in the online documentation of EODAG. So the first things that change are all the properties of the search results that are renamed. This impacts both the keys and the values of the properties. So I'll show you an example. So I just instantiated the EODAG object and performed the search on the PEPS provider. Yes, so here we have some results. And we can see that previously we had a product type attribute that is now called collection. Date times attributes are also renamed. And if you have a look to the remaining properties, we can see that they are all stack formatted. And some are particular to the provider. These ones with the PEPS prefix are the properties returned by the provider and that are unknown and have no stack equivalent. So they are returned as is with the PEPS or the provider prefix. And we also have, yes, some with the EODAG prefix that are properties used internally by EODAG. The values are also standardized. We can see that, for example, the grid code has been standardized using the recommended format, the recommended format by the stack extension. Yes, so that's why we can have a detailed look to all the properties that were renamed. So that's the list that is on the documentation. So yes, the main one is the product type that is now renamed to collection, and then we have all the remaining properties with their name that was used in version 3 of EODAG, and now in the new name that is used in the version 4. So yes. So this is for the properties of the search result, but the queryable were also renamed. For an easier usage in Python, we can replace the colon with an underscore to make it easier to use with Python, and EODAG will make the translation before sending to the provider. We can have a look, for example, to the queryable available for PEPs. So we can see, for example, for snow cover, that the colon was replaced by an underscore. Both work because we can see that there is an this uses pydantic, and we can see that there is a pydantic alias that uses the colon. So this means that both work. And for this parameter, we can also see that in the queryable some pattern or some restrictions can be defined. Here you can see that it should be greater than 0 and less than 100, for example. But we have also for the grid code parameter a pattern that is expected. Yes, so that's for the queryable. And here is an example that uses both ways to write the parameters with an underscore or with the colon, and we can see that both worked. Yes, the grid code, we can see it, 31 TCG, and the cloud cover is also, you can see it in the quick look or in the properties. It is less than 10 as expected. Another feature that comes with this new version is the search validation. It uses the queryable. So by default, all parameters are checked using the constraints in the queryable. So if, for example, we use a string as search value for the cloud cover, EODAG will fail before sending the request to the provider. We can see here the validation error, and this can be disabled using the validate parameter and set it to false. And by doing this, the request is sent to the provider, and we can see here that we got a request error, meaning that the provider returned 0. Yes, that's it for the validation. So this new version comes also with some updates on the API. We can have a look to the renamed methods here. So the method to get the available providers is not renamed, but it now expects a collection parameter instead of a product type. The method that is used to discover product types is now renamed to collections, etc. All the methods that were used for product types are now renamed with collections. yes, I can show you a small example of, for example, the guest collection method that was previously guest product type. It expects this method expects parameters that have also been renamed using the stack parameters. So here we want to guess collections configured in EODAG that are for the Sentinel constellation and L2 processing level. So we have this list, and this method also accepts free text search. So we can use it to search for example, for Landsat collection 2 data collections. Sorry. We also got updates for the command line interface. So this is also detailed in the migration guide. Yeah, I will show you briefly the method that are available through the command line. So you can use from the command line EODAG and then the command discover to discover collection, download to download a product or a list of products that were previously searched, list to list collection, search to perform a search. And yes, we can see here that the interface was also updated to use stack parameters. So here we can see that we use the collection instead of the product type. And yes, all search parameters were renamed. Yeah, so that's an example of the help prompt we got from the EODAG search command line interface. So EODAG also uses can use environment variables to configure its core engine. So some of them had to be renamed. So these are these three environment variables. The first one, EODAG collection file, is to set the path to the internal catalog of the collections. And yes, we have three environment variables that had to be renamed. And yes, that's it. Some files are had also to be renamed. So this we have this list of files. This can be useful for contributors or people working on forks of EODAG. But yes, it is not very important for the end user. That's it for the usage of stack metadata. Regarding the new video CIDA provider, so this new provider exposes the ESA CCI open data through this new provider. It was available from the 3.8 version of EODAG. No credentials are needed to search or download on this provider. We had some work to create collection names using the collection metadata to make it usable. And we also had to filter returned assets to only keep the one that could be downloaded. So I will show you an example of how to use this provider. So here we list the available collections for this provider. So yes. Yeah, so we have more than 300 collections, and we perform a search on one of these collections. Here we can see we got 24 results. So if we have a quick look to one of them, we have some basic properties on it, and we have two assets. One NCDF and one JSON file that is a car chunk. And then we'll use the 2x-array method of EODAG to get the data as an X-array. Yes. Here it is, and then we can plot it. Yes, so here is the data plotted, and we can also download the data. Yes, and it was downloaded in the TMDR. I will briefly show you some of the another feature that was recently added in EODAG. So that's a feature that allows to pre-sign the URLs for LWS authentication plugin. So if I try to perform a search on the search provider, for example, yes, the returned assets are hosted on AWS. We can see it here, for example. Yes, you can see S3. And yes, using this method, we can generate a pre-signed URL directly that can be downloaded without another need to set credentials. And also to come soon in EODAG. So there are already pull requests that are ready to review, and this will be merged in shortly. So the first one is an update of the pagination system. We'll now use a Python generator instead of a page parameter that needed to be set manually. Also, we will have Python objects for collections and providers to enhance the representation in notebooks, and also benefit from advanced method on these objects. A new provider for Copernicus global human settlement layer, and also for Copernicus data space ecosystem through their S3 through their S3 to download the data and have access to individual assets on it. Yes, and that's
checking
it.
in nearly. Okay, perfect. So that.
Thanks, Sylvain. Yeah, that was excellent. Yeah, really good. All the stack improvements are really helpful.
Yeah, so if we just have any further questions in the chat, I think we need to move on, just to be able to wrap up the meetings. Everyone on the continent has a decent time to eat their lunch.
Yes.
So yeah, so Bernard, so you went off mute. So if you want to go for it.
Yes. Can you hear me?
Yes, can hear you.
Perfect. Yes. Okay, share my screen. Should be this one. Yes.
Yeah, we can see your slides. Yeah.
Okay, perfect.
Yeah, you got 15 minutes. Go for it.
Thank you. During my presentation and the demo, I will explain what happened to the application quality recently. So the application quality building block, and then after me, Thilo will describe their work on the resource health building block. So here we have a summary of the tasks worked on since the beginning of the project, but at the bottom you see that in quarter 6, this quarter has been quite lightweight because we worked on 2 tasks mostly. The first one is we have added the ability to use virtual clusters from Workspace, so user workspaces, to execute analysis pipelines. So this is another way to run the pipelines in sandbox environments. And the second task was to implement additional dashboards and visualization panels for the analysis reports. So I will show that in a minute. Yes, this slide has not changed. It's just to remind about the different components that are implemented in the application quality building block or service. We have the API, which is the backend where the logic is implemented. It is used to store all the information about the pipelines, the executions, and the reports in the database behind it. We have the web portal, which has been implemented specifically for the application quality. And we have the dashboard that is actually implemented using Grafana, in which we have the visualization panels. Behind the scene, we are using Calrician with the embedded CWL runner to execute, to run the pipelines in the virtual clusters. This has been updated because now we are showing that the application quality backend can use, so it's an option, it's not mandatory, can use the Workspace building block and its API to obtain the configuration of the virtual clusters of the users. So when a user executes a pipeline through the user interface, the backend can obtain the information to execute the pipeline in the virtual cluster. So here on the right side, we have represented the workspace. Inside the workspace, the virtual cluster, and inside the virtual cluster, we have a job running orchestrating the execution of the pipeline. The execution of the pipeline is done as before. What has changed also is that when a report is saved back to the database through the backend API, it is using the external address of the backend. So it goes through the ingress typically and the authorization layers. Yes, we have 3 levels of dashboards. We have one pipeline executions dashboard that shows on the timeline all the executions of the pipelines. For each execution, we have a different pipeline execution dashboard, as we showed on the right side. And this lists, for example, the reports that are available. And then we have one dashboard for each type of report, with each instance of report. We had previously reports for dashboards for Pilot and Rough, and we have added Flake 8, Bandit, Trivi, and the notebook best practice validator. Now to the demo. Yes, I will execute 3 different pipelines because actually the dashboards or the visualizations we have added apply to Python code, to the Docker images, and to notebooks. So I have to execute the 3 to show that it works. I will use a text-based tool to show that the pipelines are actually executed in the Alice of the workspace cluster of the test user Alice. And then we will look at the dashboards that have been generated, so showing the reports. here. Voilà. So here I'm in the, maybe I can, yeah. We are in the web interface of the application quality service. We have a page with the list of available tools, but they cannot be executed directly. They have to be organized in pipelines. And here we have the pipelines I mentioned before. I will immediately execute them because it take a couple of minutes. Here we have the Docker pipelines. It executes the Trivi tool, and Trivi checks for the vulnerabilities in the Docker images. So I execute this on a previous version of the application quality backend, so to check if the it contains vulnerabilities. So I start this execution, and now I can move to the cluster itself to show that the pipeline is executed in the virtual cluster of Alice. Here we have the kubeconfig file of the Alice virtual cluster. We can see that actually this is now, but in GMT. So this has been retrieved dynamically from the cluster, and I will use it to inspect what is going on inside that virtual cluster. So I used K9S here to inspect what is going on. So we see that a job has been created. This is the job of running Calrissian. We see that yes, a namespace has been created for this new execution. It has been created a few seconds ago. It contains, for example, the CWL workflow that implements the pipeline. Here it is. And here we see that. So here we have a Trivi sub workflow, and we have a Trivi command line. Is it? Yeah, I don't really have time to search for it yet, but we have here the command line tool. So what's happening in the pods? Here we have, yes, the main job. We have Trivi, which is testing, analyzing the Docker image. So he fetches the Docker image, he analyzes the Docker image, and then he generates a report. The report is then saved in the backend. If I look at here, yeah, I should start the polling. Yes. So here the pipeline is still running, but the report is already available because I see progress 1.1. If I look at the reports, I can inspect them here in the user interface. But of course, as I've already demonstrated before in the previous meetings, it's not user-friendly. So we can instead, my screen is locked. No, wait. Sorry for that. I can inspect this in Grafana. So in Grafana, we have the pipeline executions. Here, the last execution is the one I've just started. It completed. If I look at the details, I see that a Trivi report is available. If I go to the report, I find the report itself presented in a user-friendly way. So we have the metadata generated by Trivi. So it's the information about the Docker image that has been tested. We have the vulnerabilities, the amount of vulnerabilities depending on their severity, group by severity. And below we have all the vulnerabilities. I can, for example, filter on them to only get the severity, the critical that have been fixed. So we can see that the version of the package that has been implemented and the version of the package where it is solved. Here we have the link to a website that describes with many more details each vulnerability. So this is for Trivi. I can do the same for the Python pipeline. Again, I can test an old version of the application quality building block that is in on Docker Hub. Again, here we have a job that will be started very soon. And check the namespaces. Yes, this is the new namespace 20 seconds ago. Actually, when a pipeline execution is finished, the namespace is deleted, so everything is removed from the virtual cluster. That's why we have only one namespace here. And the job, yes, voila, the job is coming. And as soon as the job is there, the pods also start running. Yeah, I can show a past execution so that we don't have to wait. So past executions here, actually I tested this morning. We have a Python pipeline here, which succeeded. We have 4 reports because there are 4 analysis tools executed in this pipeline. We have a RUF here with, again, information about the file, what is wrong inside the file, information about the location in the file where there is a problem, how it can be fixed, and again a link to the RUF website that describes with more details the problem. We have that for RUF. We have that for Flickate here, the same. We have this with Bandit, and Bandit does not check the layout, I would say, of the syntax, but it checks also the vulnerabilities, but inside the Python code. So, for example, here it detected that there is a possibly hard-coded password in one of the files, and here as well. So it complains about it, of course. And again, we have links to external, to the official Bandit documentation with more details. Bandit and then PyLint, that's for the linting. So if the code is not formatted according to the best practices, then we have some messages there.
Christoph has his hand up. Do you want to ask a question?
Okay.
Can some of these checks be silenced or used by a whitelist file or something? Because sometimes when an application gets developed and you get dozens of warnings or security warnings which maybe don't really apply, and you say, okay, I checked it, I want to skip it next time.
Yeah, yes, indeed. Actually, we have implemented that for a few of the tools, and this can be adapted quite easily. So, for example, when in the Python pipeline, which includes 4 tools, we have here we have for Bandit, it's just a verbose flag, but for others we have added the possibility to ignore some warnings and some errors. So here you can provide a comma separated list of IDs and they will be ignored. They will not be reported. We have not implemented that for all the analysis tools, but it's very easy to adapt because the tools are actually specified as command line tools, so CWL fragment in the database. So it's easy to add parameters to configure the behavior, to adapt the behavior of the tools. So the answer is yes. It has been implemented for some of the tools, and if necessary, it can be done for others as well.
My idea was that with your application, provide this configuration file, because it's application specific what I should ignore. But yes, this is a good start.
Yeah, actually, yes. Here, those default values, actually, on one side, you have the analysis tools. And if you look at PyLint, for example, you see that here the PyLint itself has 3 parameters: disable with the list of IDs, verbose, which is a Boolean, and errors only is also a Boolean. So this is the tool. And actually, with the tool, you can create many pipelines. And in each pipeline, you can configure the default values. So here, Python pipeline, I can edit the pipeline. And when I edit the pipeline, I can define default values. So what you can also do is create a different pipeline for different type of applications.
Sounds like a workaround, yes, but it's a good start. Let's see how it performs for the users. Thank you.
All right. Thanks, Bernard. Are you finished? Just we're moving on to Thilo now.
Yes, so I have not executed the notebook static analysis.
Oh, sorry.
Yeah.
I took over the screen now. Do you want me to give it back?
No, okay. So there was a last report, the type of report that I wanted to show, but actually it's similar. It's the report that shows the problems detected in the Jupyter notebooks. So when Jupyter a schema is applied to a Jupyter notebook, but it's really the same principle that the other report. So it's fine. You can go.
Okay, thanks. Sorry about that.
Thank you.
Thank you.
No
Was a bit
problem.
hasty. Okay, I think you can see my screen. At least I can see my own screen on my phone.
Yeah, coming through.
Very good. So I think I can keep this relatively short. So for us, this has also been a relatively low intensity quarter. We've focused mainly on filing some rough edges and doing maintenance work and trying to gather some feedback. So one of the main goals was to have a demo session with Earth code, which we did, and I'll get back to that in a little bit. So the main actual implementation work or maintenance work has been on the highlighted part here, meaning on the web interface and a bit on the API endpoints. And we've also done some behind the scenes work, as we've already heard, on the notifications side of things, but there won't be much visible there, but I'll mention that as well in a minute. So in general, we're at the stage where we're hoping to gather feedback and react to feedback and prioritize things based on users more than sort of doing large development of the building block. And I'll make some notes about that at the end. So one of the biggest sort of software changes, or where we've done a lot of refactoring and improvement, is in the implementation of hooks. So as a reminder, hooks in the API endpoints is what we use to implement various things, maybe most importantly, authorization and authentication. So basically they are operator provided little callbacks that we use to determine access rights and things like this. But in principle, it's also what we'll use for generating notifications. You could use it for additional logging or whatever you need. So what we've done there is we had sort of 2 separate implementations of all the logic there for the different API endpoints. So we unified that into some common implementation. And we made it easier to add multiple hooks by just allowing the operator to put multiple files basically with different hooks, implementing different logics next to each other. So if we go to the examples that we have in the repository, we see two separate ones. So these are the ones loaded in the development cluster. The one is the basic one implementing the integration with the IAM building block that forces you to be logged in through OpenID Connect. And then we have one intended for, as an example, sort of what operators can do to customize things. And this was a specific request we had a while ago to control the frequency of created health checks, like the frequency of execution. So here we did an example of what type of custom logic you might want to implement. And this looks at the cron expression before creating a hook and says that for a certain expensive type of health check, you're not allowed to do it more than a few times a week. I think there have to be at least 3 days between runs in this example. So the way this works is you can then just drop a file containing functions with the right name. So in this case, on check create in a certain directory next to the API endpoint. In the development cluster, we've done this through config maps, just because that's easy to integrate with our deployment and with Argo CD. But in principle, that could be a shared volume or anything. So you can see we have the same script, just literally copy pasted here into a config map that gets mounted into a directory next to the API endpoint. So the idea is that gives you a flexible way to integrate if you have more complex authorization. It also allows you to choose the Kubernetes cluster where cron jobs are created. So if you wanted to use the V clusters, you could add a hook here so that it would find the right V cluster based on, say, user identity or so. So that has been improved in this sense that I just showed, where you can just add additional files to add additional ones. We've also improved the ergonomics a bit, and especially related to generating exceptions inside these. So if you want to indicate that there's an error. So now I realized in my browser just yesterday when I was preparing the demo, there's a formatting bug. So it won't look quite as nice as I was hoping, but just to illustrate the idea, this is the expensive type of check will be denied. Oh, I should also just update this because I need to log in. Yeah. So just to illustrate the idea, we had the rule that this expensive type of check should not be allowed if we schedule it often. Will hopefully not work, and I'll add a schedule telling it to run every minute. Input here don't matter. So now here's the formatting issue in my browser. Sadly, this should be line wrapped, but it gives us the error message that we need at least a 3-day period between executions for this type of health check. And this is in principle something that an operator would provide, or we could provide examples that the operators then customize and just put in the directory, and all the error information gets propagated to the end user in the interface. Yeah, so that's one of the big things where we spend some time improving things, because it allows us to more easily also respond to feature requests of this type. Then we had the demo with a new example health check for a collection. So this uses the records API. So we have a slightly larger example there of drilling down into a data set and checking for the presence of certain records. So we ran this this demo a while ago, so we hopefully raised some interest in using this with Garin and Francesco.
What was the check? What check specifically was being performed there, Thilo?
So I can open it. So it drills down into a collection, finds, checks whether certain items are available in that collection, and then just says, okay, if it can follow it. And this involves multiple hops. So it's an example of sort of drilling down into a data set with multiple requests, checking that all the requests work and that the necessary data is present.
Okay.
That's an ice elevation data set in this case. So this has been running now in the cluster for a while. We have this as a running example. It's been working mostly. It failed once. So I'll get back to why in a second. So the idea is also to use the same structure for the demo video that we've also been working on preparing. It's not quite done yet. So for this session, we illustrated how to create these health checks, how to diagnose the outputs, and a bit the dashboards and what you can do with the dashboards. So that's also, we have a recording of that meeting in case we want to put that somewhere. Some minor fixes in the web UI. We've improved certain things in the UI. We've added timestamps so you can see when the runs happened on the side. We fixed some issues in the way we represent telemetry. Yes, we had some round tripping issues, but now if we wanted to look at the failed test run, for example, this is now completely correct, hopefully, OpenTelemetry data, which means that we can, for example, open it in OpenTelemetry desktop viewer. Yeah, and here we can see if we look into what happened, we see that one of the internal requests to the API just took very long, especially if you compare it to another, and it gave a 502 error. We can see exactly the endpoint it went to and so on. So this is why one of the reasons why we like relying on OpenTelemetry. You have pre-existing tooling to sort of look into the details of the health check execution. So various minor fixes there in the UI. Backend work, as I said, we have an example with notifications that we finally got working, but it's not properly integrated yet. So that's one of the big things that we want to work on in the future, is to go from this example into having actual configurable user notifications. Otherwise, we also have a bit of work to get authentication working with the CLI and sort of notebook access. And there's still some documentation things to work out that we for the OpenSearch storage. And in general, still, we love to hear feedback from users. So hopefully we can get some active users so we know where to put our priorities. So that's all from my end.
Right, thank you very much. Okay, if we haven't got any questions there, I guess we can call it a day. Thank you very much for all the well done for all the progress and the demos. Thank you very much for that. The idea is to bake all of this into the release. There's a bit of process on our side to go through regarding that. So we will take that into the deployment guide and then validate it, I think, via some work we'll continue to do on the tutorials that will help us validate that. We'll base that on what's in the dev cluster. So on that topic, Marion, what I'd like to do is very quickly upgrade the cluster so that you can push your latest and greatest into it. So that's top priority, I think, on our side. Otherwise, no more to say, really. Thank you very much.
Just 1 second, some closure remark. Our objective as EOEPCA till the end of the year will be to publish a stable 2.0 release. So now that I will consider, let's say, most of the functionality of the building blocks implemented in this release by what you've shown. Of course, there will be further evolution, but the focus in the next months of Richard and the EOEPCA team will be actually to build the documentation, verify that the components are stable, verify that is understood what they provide, what is their functionality, how they are deployed, etc., etc. So for the next release, we will have a, let's say, more stable 2.0 version, stop sending people to the 1.4 and start sending people to the new components. Of course, this does not matter so much for the components who are already stable in some 1.4, who are the catalog, etc. But for the new ones, it's very important. Yes, Angelos, please.
One question regarding that: should we avoid adding new features to the current upstream for the next few months until we get, you know, 2.0, because, you know, this could be a source of regression. So
yes. You should concentrate to making the software stable. But of course, if you have in plan adding new features, you can still keep adding them. What may happen is that in the 2.0, we actually, let's say, lose. I mean, we will run some regression and testing, and if some new feature introduce a new regression, we may actually include in the 2.0 EOEPCA stable the previous version of the component.
So maybe we could cut a release candidate 3, then from
Yes.
that we can continue working, and if we find regressions, then we release the release candidate 3 as stable and we move on.
Yeah,
that's actually a good idea. The next release you can tag it as release candidate 3, and Richard will then tag it at release stable release 2.0, ensuring after that there is no regression.
Yeah, and we can
it will
also
work
use
as the base. It will work till the end of the year with the base of the release candidate 2, of course, and update all documentation in that, and then decide soon after the next demo event if we go live 2.0 with the RC2 or the RC3 version, according to the change in the stability in itself of the component. I mean, I would expect most of the component to be stable right now, and I would expect the changes between 2 and 3 not be much. So, but it was very good to point that out, Angelos.
Yeah. And with that baseline, that should also give us the opportunity, if we needed it, to separate a needed bug fix before release from a feature that is future as well.
Yes.
So
to continue, I would also recommend you, all the building block developers, to be responsive to Richard's request for, let's say, bug fixes, as he was saying. I mean, I know you tested this, I know you have deployed it in the reference cluster, but when Richard will try to deploy it in another system for reference, maybe some new things will be discovered. If that happens, I hope you will give to it a good priority so that we can reach this stable version and we can verify everything. That is maybe another thing which I want to say to everyone is also that there will be a DCB, an internal ESA board meeting in a month. And we plan also there to highlight the EOEPCA, the effort that we did, this new stable release that is coming at the end of the year. Let's say the collaboration and the fact that EOEPCA is bringing, let's say, effort together from different actors in the European world, and not only, let's say, development sponsored by ESA, but also development done by the community, by other entities, member states, or even people who is out of ESA. So this is what we will try to do. Of course, and it's very relevant for us because we want to frame EOEPCA as a success for the upcoming ministerial. And last thing, it's a managerial thing. Of course, Chandra and Richard, we need some minutes of this meeting and the recording to, let's say, approve.
Yeah, so if everyone could get me their work orders, we've got our review on Monday for this past quarter, and hopefully we can get the work order through the system quicker than last quarter. So.
Okay, thank you very much, everybody.
Thanks everyone who stayed to
Thank
the
you
end,
all.
and thanks everyone for your contributions, for the good work.
Bye.
Okay, bye.
Bye bye.
Thank you. Have a good one.
Bye.